In the archaeological layers beneath the city of Eridu, where excavators have traced 17 distinct building levels down through the centuries, there is an anomaly that creates quiet problems for conventional chronology. The lowest levels, the oldest structures, do not show the expected crudeness of early experimentation. The brickwork is precise. The drainage systems function with mathematical efficiency. The temple foundations align to stellar positions with accuracy that requires generations of careful observation to achieve. Yet these are supposedly the first attempts at urban architecture in human history. The structures that should be rough and uncertain are instead sophisticated and deliberate, as though their builders already knew exactly what they were constructing. The Sumerian civilization appeared in southern Mesopotamia around 3500 BC with a completeness that archaeological models struggle to explain. Most cultures leave evidence of gradual development. Pottery becoming refined over centuries, tools slowly improving, settlements expanding from simple to complex. The Sumerian record shows little of this progression. Their earliest artifacts display capabilities that suggest inheritance rather than invention. Perhaps you are listening now in the quiet hours, when the day's concerns have settled and the mind is free to consider questions that daylight makes difficult to hold. You are in good company. These questions have been asked before in older languages, and the answers they found were carefully preserved in clay. If this resonates, consider subscribing. We continue now. The mathematics alone creates discomfort. The Sumerians used a base 60 numerical system, the same system we still use for measuring time and angles. This is not a simple counting method. It requires understanding of factors, divisibility, astronomical cycles. The system appears fully formed in the earliest texts, without evidence of the experimentation that precedes most mathematical innovations. Their metallurgy was equally sophisticated. Bronze alloys found in early Sumerian sites show compositional ratios that modern metallurgists recognise as optimal for strength and workability. These are not the first attempts at metal mixing. They are refined solutions that suggest either impossibly rapid learning or access to knowledge that predates the archaeological evidence. The astronomical observations are perhaps most troubling. Sumerian tablets describe the precession of the equinoxes, a 25,120-year cycle caused by Earth's axial wobble. Detecting this phenomenon requires continuous sky observation, spanning multiple human lifetimes. Calculating it precisely demands mathematical sophistication that conventional timelines do not allow for this period. But there is something in the Sumerian records that creates a different kind of unease. A document that appears in multiple copies across different archaeological sites, each version reinforcing the others. The Sumerian King List presents itself not as mythology, but as administrative documentation, a chronological record of rulers organised into clear categories with specific durations attached to each reign. The list divides Sumerian kingship into two distinct periods, before the flood and after. This division appears consistently across all versions of the text, suggesting it represents an actual historical boundary rather than symbolic framework. But the numbers assigned to the pre-flood period do not behave like normal historical chronology. The tablet states that after kingship descended from heaven, the kingship was in Eridu. The first king, Alulim, ruled for 28,800 years. The second king, Alaugar, ruled for 36,000 years. 8 kings total are listed for the pre-flood period, with combined reigns totalling 241,200 years. Academic consensus treats these numbers as mythological exaggeration, symbolic representations of dynastic periods, or cultural memory compressed into individual reigns. This interpretation resolves the chronological impossibility, but it does not explain why the numbers follow specific mathematical patterns. why they appear consistently across independent sources, or why they are recorded with the same precision used for post-flood rulers whose reign lengths align with more reasonable historical periods. The pre-flood numbers are all multiples of 3600, a unit the Sumerians called a sar. This is not random. The sar appears throughout Sumerian mathematics and astronomy as a fundamental unit for measuring long cycles. The precision suggests these were calculated periods based on specific temporal measurements, not arbitrary figures chosen for dramatic effect. After the flood, the King List records a shift. After the flood had swept over and kingship had descended from heaven, the kingship was in Kish. The post-flood rulers show dramatically reduced reign lengths. Etana of Kish ruled for 1560 years. Meski-Agasha of Uruk ruled for 324 years. The numbers remain extraordinary by modern standards, but follow a clear pattern of decline toward normal human lifespans. The mathematical relationships embedded in these chronologies indicate understanding of astronomical cycles that modern science has only recently confirmed. The SAR unit of 3,600 years corresponds to specific orbital periods and celestial alignments that require sophisticated observation to detect. The King List appears to be documenting something more complex than simple political succession. Archaeological excavations at sites predating the earlier Sumerian cities provide fragmentary support for the existence of advanced pre-flood cultures. Tel Essaouan has yielded pottery and architectural remains dating to 6000 BC that display technical sophistication, suggesting continuous cultural development rather than sudden appearance. The artifacts show knowledge of mathematics, astronomy, and engineering that the conventional narrative places thousands of years later, but the site that creates the most significant chronological problems sits in modern Turkey. Göbekli Tepe, dated to approximately 9600 BC, consists of massive stone pillars carved with intricate reliefs and arranged in circular complexes according to astronomical alignments. The engineering required to quarry, transport and erect these stones demands organisational capabilities and technical knowledge that should not exist in the Neolithic period. The pillars show evidence of precision stone carving, not the crude pecking marks of primitive tools, but clean cuts and detailed sculptural work that suggests advanced techniques. The astronomical alignments incorporated into the structure's orientation indicate understanding of celestial mechanics that requires long-term observation programs. Most significantly, the entire complex was deliberately buried around 8000 BC, filled with rubble in what appears to be a conscious effort to preserve the site. This deliberate burial raises questions about intention. Why would a culture invest tremendous effort in constructing sophisticated monuments only to carefully inter them beneath tons of earth? The act suggests knowledge of coming catastrophe, or perhaps a recognition that knowledge itself needed protection through a period when it could not be actively maintained. The Sumerian texts themselves reference this earlier period. Cuneiform tablets describe the Anunnaki, entities they identify as those who from heaven to earth came. These beings are credited with establishing the first cities and teaching humans the foundational arts of civilization. The tablets present these accounts in matter-of-fact language that resembles historical chronicle rather than religious mythology. The text known as the Eridu Genesis describes how the Anunnaki established urban centres and provided instruction in agriculture, metallurgy, astronomy and governance. The precision of the technical details in these accounts, specific measurements, construction techniques, astronomical observations, does not read like symbolic religious literature. It reads like documentation. The descriptions include physical characteristics and technological capabilities. Flying vehicles called divine boats and whirlwind chariots that used brilliant fire for propulsion. These accounts, written thousands of years before human aviation, suggest either remarkable prescience or direct observation of technologies that conventional chronology does not accommodate. Academic scholarship dismisses these descriptions as mythological metaphor, primitive attempts to explain natural phenomena or political authority through supernatural frameworks. This interpretation maintains chronological coherence, but it requires treating the Sumerians as less sophisticated observers than their mathematical and astronomical achievements suggest they were. The question that emerges from this evidence is not whether the Sumerians were technologically advanced. The surviving artifacts confirm their capabilities. The question is where their knowledge originated, whether they developed it through the rapid indigenous innovation that conventional models require, or whether they inherited it from sources that predate the current archaeological framework. The King List's reference to pre-flood rulers with impossible lifespans, the mathematical precision of their astronomical calculations, the sudden appearance of urban sophistication without evident developmental stages, these patterns suggest that Sumerian civilization may not represent humanity's first attempt at complex culture. The evidence points towards something that creates a particular kind of tension in the historical narrative. The texts say there were civilizations before. That knowledge was preserved through catastrophe, that what we see in Sumer is not beginning but continuation. The continuation appears not in speculation but in physical evidence distributed across the planet in patterns that resist conventional explanation. More than 500 cultures scattered across every inhabited continent preserve detailed flood narratives containing technical specifications so consistent that they challenge the independent invention hypothesis. These are not vague tales of divine punishment. They are accounts with specific durations, water levels, and survival protocols that read like incident reports rather than religious allegory. The Hopi tradition describes a world destroyed by water when the blue star Kachina appeared in the sky. Their account specifies that the flood lasted exactly 150 days, matching precisely the duration given in Mesopotamian sources separated from the American southwest by oceans and millennia. The Hopi describe survivors taking refuge in hollow reeds that floated on the water's surface, a detail that parallels the Sumerian account of Utnapishtim's sealed vessel with technical precision that suggests shared observation rather than coincidental invention. The Cherokee preserve accounts of the Nantahala people who escaped the great waters by building boats sealed with pine pitch. The construction detail, pine pitch as waterproofing sealant, appears in cuneiform tablets describing ark construction techniques. The material science is identical across cultures that supposedly had no contact. Australian Aboriginal Dreamtime stories from the Bunjalung people describe the Great Flood of Narajdan, which occurred when the rainbow serpent stirred the waters and drowned the ancient world. Their oral traditions specify temporal markers. The waters rose for 7 days and 7 nights, remained at peak level, then gradually receded. These chronological details align with flood sequences recorded in ancient texts from cultures on opposite sides of the planet. The Maasai of East Africa preserve accounts of Tumba, the great flood that destroyed the first world. Their tradition describes how Tumba warned one righteous man to build a boat and take animals aboard before the waters covered the highest mountains. The narrative structure matches Mesopotamian accounts, but the construction materials specified, acacia wood and animal skins, reflect resources available in the East African environment. The technological adaptation suggests practical knowledge rather than copied mythology. Polynesian cultures maintain flood traditions that predate their arrival on current island homes. The Tahitian account describes the god Ta'aroa causing waters to rise until only the highest peaks remained above the surface. The tradition specifies that the flood occurred during a time when the stars danced differently in the sky, a reference to astronomical disturbances that appears in flood accounts from Hawaii, Samoa and New Zealand. The consistency of celestial anomaly descriptions across isolated island populations suggests observation of actual astronomical events. The technical details extend beyond duration and water levels. Multiple traditions describe unusual animal behaviour preceding the inundation, birds flying in confused patterns, domestic animals showing extreme agitation. The Lakota tradition mentions buffalo herds moving in circles. Mesopotamian texts describe similar disorientation among livestock before the waters began rising. These are not the kinds of details that travel well through mythological transmission. They are the kinds of observations that survivors remember. Seasonal timing appears consistently across accounts from different hemispheres. Many traditions specify that the catastrophe occurred during what would correspond to late spring or early summer in the northern hemisphere. The Aztec tradition places the flood during the time of the growing corn. Celtic accounts describe it happening when the oak leaves were full. This seasonal specificity across different calendars and climate zones suggests a global event occurring during a particular astronomical period. The geological record provides confirmation that conventional history has been reluctant to fully integrate. The Younger Dryas period, a dramatic climate event occurring between 12,900 and 11,700 years ago, represents one of the most rapid and severe environmental changes in Earth's recent history. Temperatures in some regions dropped by 15 degrees Celsius within decades. Ice core data from Greenland shows the climate shift occurred within a single human generation. The Grip ice core reveals more than temperature change. The atmospheric composition shifted dramatically, showing increased levels of dust, volcanic ash, and unusual chemical signatures indicating massive environmental disruption. Antarctic ice cores demonstrate that the climate change was global, affecting both hemispheres simultaneously, not a regional phenomenon but a planetary catastrophe. The period coincides with the extinction of numerous megafauna species across multiple continents. Mammoths, giant ground sloths, cave bears, saber-toothed cats. Approximately 75% of large mammal species in North America disappeared within a narrow time frame that matches the Younger Dryas onset. The extinction pattern shows remarkable synchronicity, as though a single event triggered cascading ecological collapse. Recent research has identified evidence of a cosmic impact that may have triggered the Younger Dryas climate change. The impact hypothesis is supported by discoveries of nanodiamonds, iridium anomalies, and shocked quartz in sediment layers dating to 12,900 years ago. These markers have been found at sites across North America, Europe, and Asia, indicating not a localized strike but a global catastrophe involving multiple impact points. The Younger Dryas boundary layer contains unusual concentrations of platinum, a metal rare in Earth's crust, but common in extraterrestrial objects. This platinum spike appears in sediment cores from locations as diverse as Greenland, Mexico, and Belgium. The distribution pattern suggests the impacting object was a comet that fragmented in Earth's atmosphere, creating multiple impact sites across the northern hemisphere. Carbon spherules found in Younger Dryas sediments show evidence of exposure to temperatures exceeding 2,200 degrees Celsius. consistent with impact-generated fires that burned across continental scales. These microscopic particles contain trapped gases with isotopic signatures matching those found in confirmed impact craters. The spherules appear in concentrations that suggest wildfires burned for extended periods across vast areas. Computer modelling of potential impact scenarios indicates that a fragmented comet striking the North Atlantic could have produced tsunamis hundreds of metres high, capable of travelling thousands of kilometres inland. These waves would have carried marine sediments far beyond normal coastal boundaries, evidence of which has been found in geological layers corresponding to the Younger Dryas period. The timing is what creates the deepest unease. The Younger Dryas event occurred approximately 12,900 years ago. The Sumerian King List describes a great flood marking the boundary between impossibly long pre-flood rains and more historically reasonable post-flood chronologies. The global flood traditions preserved in 500-plus cultures describe catastrophic inundation accompanied by celestial disturbances. The geological evidence confirms planetary scale catastrophe during the precise period when oral traditions place the Great Flood. The convergence of textual tradition, oral history, and physical evidence suggests that the flood narratives preserve actual historical memory, not metaphorical spiritual teaching, but documentation of real events that survivors considered important enough to preserve across thousands of years through careful cultural transmission. But if the flood accounts are historical rather than mythological, then other elements of those same traditions may also document real events. The Sumerian texts describe advanced pre-flood civilizations possessing knowledge that post-flood cultures had to gradually relearn. The King List's impossibly long pre-flood reigns may not represent individual lifespans, but dynastic periods or cultural epochs that were catastrophically terminated. The question shifts from whether a catastrophic flood occurred, the evidence increasingly supports that it did, to what existed before the catastrophe. What level of civilization did the pre-flood world achieve? What knowledge did they possess? And most significantly, how much of that knowledge survived the disaster through preservation by populations that the ancient texts consistently describe as having received advance warning? The flood narratives share another consistent element beyond duration and timing. They describe selected survivors who received specific instructions for constructing survival vessels and preserving genetic material, both human and animal, through the catastrophe. The accounts present this as deliberate preservation rather than random survival, suggesting organised effort to ensure knowledge continuity. The Mesopotamian accounts provide the most detailed technical specifications. The Epic of Gilgamesh describes Utnapishtim's boat as cube-shaped, 7 stories tall, divided into compartments with waterproof ceiling. The dimensions are precise, 120 cubits on each side, constructed using specific materials and techniques that would ensure stability in turbulent conditions. These are not mythological exaggerations, they are engineering specifications. The Genesis account provides parallel details. Noah's Ark measured 300 cubits long, 50 cubits wide, and 30 cubits high, dimensions that naval engineers recognise as producing exceptional seaworthiness. The structure included 3 decks, ventilation systems, and compartmentalised storage. The specifications describe practical marine architecture designed for long-term survival in catastrophic conditions. Both traditions emphasise preservation of breeding pairs, genetic samples sufficient for ecosystem reconstruction after the waters receded. The instructions suggest understanding of population genetics, minimum viable populations, and the bottleneck problem that would result from catastrophic species reduction. This is not primitive flood mythology. This is documentation of a genetic preservation protocol. The accounts describe not merely human survival, but knowledge preservation. Selected individuals received advance warning and detailed instructions, implying that information about the coming catastrophe was available to those who possessed the capability to interpret the signs. The texts suggest that understanding of astronomical cycles, climate patterns, or geological processes enabled prediction of the disaster. If pre-flood civilizations possessed such predictive capabilities, then their knowledge of celestial mechanics, planetary dynamics, and long-term cyclic patterns was far more sophisticated than conventional chronology allows. The question is where that knowledge originated and how it was transmitted to post-flood survivors who would rebuild civilization from scattered remnants. The underwater archaeological evidence provides physical confirmation that advanced civilizations existed in areas now submerged beneath rising seas. These are not mythological sunken cities. They are documented archaeological sites with measurable structures, datable artifacts, and engineering characteristics that challenge assumptions about when and where urban civilization developed. Off the coast of Gujarat, India, marine archaeological surveys have located the ancient city of Dwarka, described in Hindu texts as Krishna's capital. The underwater ruins extend over several square kilometres at depths up to 40 metres, indicating a city of substantial size that was inundated when sea levels rose. The structures include massive stone blocks, walls, gates, and what appear to be harbour facilities constructed from precisely fitted megalithic elements. Carbon dating of organic materials found within the Dwarka structures indicates construction periods spanning several millennia, with the oldest elements dating to approximately 9,000 years ago. This places the city's founding during the period when sea levels were rising following the end of the last ice age, precisely when the flood traditions describe catastrophic inundation. The construction techniques observed at underwater Dwarka demonstrate sophisticated engineering knowledge. Interlocking stone joints designed to withstand seismic activity and tidal forces. Harbour facilities with docking areas for large vessels. Urban planning that suggests maritime trade networks. This is not primitive settlement. This is advanced urban civilization that was engulfed by rising waters. Near the Japanese island of Yonaguni, underwater surveys have documented massive stone structures that show clear evidence of artificial construction. The Yonaguni monument consists of stepped pyramids, terraced platforms, and what appear to be ceremonial pools carved from solid bedrock. The structures display geometric precision, right angles, straight edges, parallel surfaces. That would be extraordinarily unlikely to occur through natural geological processes. Tool marks visible on the stone surfaces show evidence of cutting and carving. The overall layout suggests deliberate architectural planning with features that appear to be staircases, corridors, and ceremonial chambers arranged in complex patterns. Geological evidence indicates the area was above sea level during the last ice age, when ocean levels were approximately 120 metres lower than today. The structures would have been submerged as sea levels rose following the ice age's end, placing their construction between 12,000 and 10,000 years ago, during or shortly after the Younger Dryas period. The dating places these monuments at the temporal boundary where the flood traditions locate their catastrophic events. The implications are uncomfortable. If advanced urban civilizations existed in coastal areas that are now underwater, then the archaeological record preserved on current landmasses represents only a fraction of human development. The cities, the monuments, the archives, anything built in coastal regions during periods of lower sea level would have been destroyed or submerged when the ice sheets melted and oceans rose. The question is not whether these underwater structures exist. They have been documented, surveyed and photographed. The question is what they indicate about the sophistication of pre-flood civilizations and what knowledge those cultures possess that survivors carried forward into the post-catastrophe world that eventually produced the Sumerian civilization with its inexplicably complete knowledge systems. And there is a detail in the Sumerian texts that creates a particular kind of tension. They describe their knowledge not as discovered, but as received, as taught by entities they called the Anunnaki, beings who came before the flood and established the foundations that survivors would build upon. The teaching narrative appears consistently across Sumerian sources with detail that reads like institutional record-keeping rather than religious mythology. The cuneiform tablets describe the Anunnaki not as abstract cosmic forces, but as physical entities with administrative roles, specific domains of expertise, and documented interactions with early human populations. The texts catalogue their names, their responsibilities, and their contributions to the development of what would become Mesopotamian civilization. Enki is described as the god of wisdom and water, credited with developing irrigation systems and teaching humans medicine and what the texts call magic, a term that may represent advanced knowledge or technology that scribes lacked vocabulary to describe accurately. Enlil, the god of air and storms, is associated with agriculture and the establishment of cities. Anu, the sky god, is presented as the leader of the Anunnaki Council, a hierarchical structure that suggests organised administration rather than pantheon of independent deities. The descriptions include technological capabilities that create chronological problems. The tablets describe flying vehicles called divine boats and whirlwind chariots that travelled between earth and sky, using brilliant fire for propulsion. These accounts were written approximately 5,000 years ago by a culture that supposedly had no conception of aviation, no framework for understanding powered flight, no experience with technologies that could produce the effects described. The standard interpretation treats these descriptions as mythological metaphor, poetic language for natural phenomena, like storms or symbolic representations of divine authority. But the Sumerians demonstrated sophisticated observational capabilities in their astronomical records and precise technical knowledge in their engineering achievements. Their descriptions of celestial mechanics and architectural principles match physical reality with mathematical accuracy. The assumption that their descriptions of Anunnaki technology represent primitive misunderstanding requires believing they were simultaneously capable of precise scientific observation and unable to distinguish between metaphor and physical description. Archaeological excavations at Sumerian sites have uncovered tablets describing advanced metallurgical techniques attributed to Anunnaki instruction. The texts include formulas for creating alloys and descriptions of smelting processes that involve temperature control, material purification, and compositional ratios that match modern industrial metallurgy. At the ancient city of Mari, tablets document procedures for bronze production that produce optimal strength-to-weight characteristics, specifications that metallurgists recognise as requiring either extensive experimentation or transmitted knowledge from sources that had already solved these technical problems. The site of Napier has yielded thousands of cuneiform tablets containing detailed astronomical observations and mathematical calculations. The text describes celestial body movements with accuracy that requires sophisticated observational instruments. Some tablets reference divine measuring rods and celestial observation chambers that enabled precise astronomical measurements. descriptions that suggest technological apparatus rather than naked eye observation. The knowledge systems described in these texts extend beyond what isolated experimentation could reasonably produce within the timeframes the archaeological record allows. The astronomical precision, the metallurgical sophistication, the mathematical complexity, these represent integrated knowledge systems that typically require centuries of gradual refinement, yet they appear in the Sumerian record essentially complete, attributed to instruction from the Anunnaki, who the texts consistently describe as having arrived with this knowledge already developed. Comparative analysis reveals that similar narratives appear in other ancient cultures with striking consistency. The Enuma Elish, the Babylonian creation, epic derived from earlier Sumerian sources, describes cosmic conflicts and renewal cycles that parallel accounts found in cultures worldwide. The text begins with primordial chaos represented by the waters of Apsu and Tiamat, from which emerged beings who eventually engage in cosmic warfare, resulting in the destruction and recreation of the world. The epic describes this cosmic restructuring not as a singular event, but as part of recurring cycles of destruction and renewal. The pattern appears in Hindu cosmology through the concept of yugas, vast ages spanning millions of years, during which the universe undergoes repeated periods of creation, preservation, and destruction. The Puranas describe multiple previous worlds that were destroyed and recreated, each inhabited by different forms of life. The precision with which these cycles are calculated suggests more than mythological storytelling. Hindu texts specify that the Kali Yuga, the current age of darkness, lasts 432,000 years. The Mahabharata describes this as the final phase of a cosmic cycle that includes 3 previous yugas, totaling 4,620,000 years, exactly 10 times the precessional period of 432,000 years. The mathematical relationships indicate astronomical knowledge comparable to what appears in Mesopotamian sources. Norse mythology presents the concept of Ragnarok, a cyclical destruction and renewal of the world. The Völuspá describes the death of gods and the burning of the world tree Yggdrasil, followed by the emergence of a new world populated by surviving gods and humans. This cyclical worldview appears throughout Indo-European cultures, suggesting either independent development of identical philosophical frameworks or transmission of knowledge from common sources. The Enuma Elish contains specific references to astronomical events that modern science recognizes as actual phenomena. The text describes disruption of planetary orbits, the appearance of new celestial bodies, and changes in the length of the year. These descriptions align with current theories about solar system instability and the possibility of periodic catastrophic events caused by the approach of massive celestial objects. Recent astronomical research has identified evidence of periodic comet showers and asteroid impacts that could account for the cyclical catastrophes described in ancient texts. The discovery of the Younger Dryas impact event demonstrates that major cosmic catastrophes have punctuated human history at intervals that align with flood traditions found across cultures. The geological markers of this event, the nanodiamonds, the platinum anomalies, the carbon spherules, provide physical confirmation that celestial impacts occurred during periods when oral traditions place catastrophic destructions. The Sumerian account of the Great Flood, preserved in texts like the Epic of Gilgamesh, contains technical details that suggest eyewitness observation rather than mythological invention. The description of Utnapishtim's ark includes specific dimensions, construction materials, and loading procedures that demonstrate practical knowledge of shipbuilding and survival techniques. The vessel's measurements produce a structure that naval architects recognize as possessing excellent stability characteristics, not the fantastical dimensions of pure mythology, but the practical specifications of engineered survival craft. The precision of Sumerian flood narratives extends beyond vessel construction to include duration periods, water level descriptions, and survival protocols that appear with remarkable consistency in flood accounts worldwide. The 150-day duration appears in Mesopotamian, Hebrew, and Hopi traditions. The description of waters covering the highest mountains appears in accounts from Mesopotamia, India, and East Africa. The specification that certain mountains remained above water as refuge points appears in Greek, Armenian, and South American traditions. This level of detail consistency across cultures that supposedly had no contact suggests either unprecedented coordination in mythological invention or shared memory of actual events. The conventional explanation that flood stories represent cultural responses to local flooding events that were then mythologized struggles to account for the specific technical details that match across distant populations. Local floods do not explain consistent 150-day durations, synchronized astronomical disturbances, or identical survival vessel specifications. The alternative explanation that these accounts preserve memories of an actual global catastrophe requires accepting that advanced civilizations existed during the pre-flood period and possessed knowledge sophisticated enough to predict or at least detect the coming disaster. The texts consistently describe advanced warning systems, preparation protocols, and knowledge preservation efforts that suggest organized response rather than random survival. The Sumerian texts attribute this predictive capability to the Anunnaki, describing how certain Anunnaki leaders provided warnings to selected humans and instructed them in survival techniques. The Epic of Gilgamesh describes how Ea, the Akkadian name for Enki, warned Utnapishtim through a reed wall, providing detailed construction, specifications and timing information that enabled survival when the flood came. This narrative of selective preservation appears in multiple traditions. The Hebrew account describes how Noah received divine warning and specific instructions. Hindu texts describe how Manu received warning from the god Vishnu in fish form. Greek tradition describes how Deucalion received warning from Prometheus. The consistency of the selective preservation theme across independent cultures suggests this may represent historical memory of actual knowledge transfer from those who understood the coming catastrophe to those who would survive it. The question that emerges is how pre-flood civilizations could possess predictive capabilities sufficient to forecast global catastrophe. The answer the ancient texts provide is that this knowledge came from the same source that provided their astronomical precision, their mathematical sophistication, and their engineering capabilities from the Anunnaki, who the texts consistently describe as having established civilization's foundations before the flood. If this framework is accurate, if pre-flood civilizations did receive knowledge from external sources, then the Sumerian civilization's inexplicable completeness becomes explicable. They were not inventing from nothing. They were reconstructing from preserved knowledge, working from fragments and instructions that survivors carried through the catastrophe. The sudden appearance of sophisticated systems without developmental stages makes sense if those systems were being reinstated rather than discovered. The archaeological evidence from pre-flood sites supports this reconstruction hypothesis. Göbekli Tepe's sophisticated stone work and astronomical alignments date to 9600 BC, before the Younger Dryas catastrophe. The site's deliberate burial around 8000 BC suggests knowledge preservation efforts. If Göbekli Tepe represents an attempt to encode and protect information through a period of anticipated disruption, then its existence confirms that pre-catastrophe populations possessed both advanced knowledge and awareness. that this knowledge faced existential threat. The underwater sites at Dwarka and Yonaguni provide additional confirmation. These cities were built during periods of lower sea level and were inundated when the ice sheets melted. Their existence demonstrates that advanced urban civilizations occupied coastal regions that are now submerged. If these coastal civilizations possessed knowledge systems comparable to what appears in the Sumerian record, then that knowledge would have been concentrated in precisely the areas most vulnerable to inundation when sea levels rose. The flood would have destroyed not merely populations, but the accumulated knowledge infrastructure, the libraries, the observatories, the training institutions that had developed and maintained sophisticated understanding over generations. The survivors who retreated to higher ground would have carried fragments of this knowledge, preserved through oral transmission and whatever portable records they managed to save. The post-flood civilizations would have faced the task of reconstructing complex systems from incomplete information. This reconstruction process explains several puzzling features of early civilizations. The sporadic appearance of advanced techniques in otherwise primitive contexts. The presence of sophisticated astronomical knowledge in cultures that lack other markers of advanced science. The common pattern across multiple early civilizations of claiming their knowledge was received from gods or culture heroes, rather than developed through indigenous innovation. The Egyptian tradition describes how the god Thoth recorded all knowledge on pillars that survived the flood. The Hermetic texts describe these pillars as containing complete understanding of mathematics, astronomy, medicine, and engineering. Everything's necessary to reconstruct advanced civilization from surviving populations. The specificity of this preservation narrative suggests cultural memory of actual knowledge storage efforts rather than pure mythological invention. The Maya described their astronomical knowledge as coming from culture heroes who emerged after the destruction of previous worlds. The precision of Mayan calendrical calculations and their sophisticated understanding of celestial mechanics suggests this claimed external origin may represent historical memory rather than origin mythology. The knowledge appears too complete, too systematic, too integrated to represent indigenous invention by a culture that supposedly lacked the observational infrastructure necessary to generate such understanding. The pattern repeats across early civilizations. Sophisticated knowledge attributed to external sources, sudden appearance without developmental stages, mathematical and astronomical precision that exceeds expected capabilities. The conventional explanation treats each instance as independent coincidence, each culture independently inventing similar sophisticated systems and independently creating similar mythologies about external knowledge sources. The cumulative pattern makes this explanation increasingly strained. The alternative framework that pre-flood civilizations did possess advanced knowledge, that this knowledge was partially preserved through catastrophe, and that post-flood cultures inherited and reconstructed rather than invented their sophisticated systems, accounts for the evidence more coherently. But accepting this framework requires accepting that human civilization's timeline extends deeper into prehistory than conventional archaeology acknowledges, and that knowledge systems existed and were lost during periods that mainstream chronology treats as prehistoric. The Sumerian King List's reference to 200 years of pre-flood civilization becomes less absurd if it represents not individual reign lengths, but dynastic periods or cultural epochs during which advanced knowledge was developed and maintained. The flood represents not the beginning of civilization, but a catastrophic interruption, a reset that destroyed accumulated infrastructure while leaving enough survivors and preserved knowledge to enable eventual reconstruction. And in the Sumerian texts, there is a detail that suggests this reconstruction was not random but guided, that the Anunnaki, who had established pre-flood civilization, did not simply vanish but continued providing instruction to survivors, helping them rebuild from ruins. The guidance narrative appears in post-flood accounts with the same institutional precision that characterizes pre-flood descriptions. The Sumerian texts do not present the Anunnaki as having departed after the catastrophe. Instead, they describe a reorganization, a shift in how these entities interacted with human populations as civilization was, gradually rebuilt from scattered survivors and preserved knowledge fragments. The cuneiform records from Nippur and Babylon document this post-flood period with administrative detail that reads like organizational restructuring rather than mythological narrative. The texts describe how the Anunnaki re-established urban centres, reinstated agricultural systems, and guided the development of governance structures that would manage increasingly complex societies. The language suggests oversight rather than direct control, instruction and coordination rather than immediate intervention in daily affairs. But there is something in these post-flood accounts that creates a different tension. The texts describe changes in human capabilities. The King List's dramatic reduction in reign lengths after the flood suggests more than symbolic transition. The pre-flood rulers, with their impossibly long reigns, give way to post-flood kings, whose lifespans, while still extraordinary by modern standards, follow a clear declining pattern toward normal human ranges. This pattern appears in other traditions as well. The Hebrew Genesis describes antediluvian patriarchs living for centuries, Methuselah reaching 969 years, Noah living to 950. After the flood, the lifespans decline steadily. Shem reaches 600 years, Abraham 175, Moses 120. The numbers decrease across generations until they stabilise at normal human ranges. The biblical text presents this as divine decree rather than natural process, suggesting deliberate limitation rather than gradual biological change. The Hindu Puranas describe similar patterns. The beings of the Satya Yuga, the golden age preceding current epochs, possessed extended lifespans and enhanced capabilities that declined through successive yugas. By the current Kali Yuga, human lifespans and abilities have diminished to their present levels. The texts frame this as cosmic decay, but the descriptions suggest systematic reduction rather than random decline. The Sumerian accounts attribute these changes to Anunnaki decisions. The texts describe deliberations among the Anunnaki Council about appropriate human capabilities and the implementation of limitations designed to prevent repetition of whatever conditions led to the flood. The description suggests genetic or biological modifications rather than merely environmental changes, adjustments to human nature itself rather than external circumstances. This framework appears consistently enough across independent traditions to suggest it may preserve memory of actual events, rather than merely philosophical speculation about human decline. If pre-flood populations did possess enhanced capabilities, whether through genetic factors, environmental conditions, or access to technologies that extended lifespan, then the flood's destruction of that infrastructure would explain the sudden reduction documented in the King List and parallel traditions. The question is whether these enhanced capabilities represented natural human potential that was subsequently lost, or whether they were the result of intervention that was deliberately discontinued after the catastrophe. The Sumerian texts suggest the latter, describing how the Anunnaki made specific decisions about post-flood human characteristics and implemented those decisions through means the texts do not fully explain. The astronomical knowledge that survived the flood provides evidence that sophisticated information systems were successfully preserved through the catastrophe. The precision of celestial mechanics encoded in post-flood monuments and texts demonstrates continuity of observational data that spans the disaster. This preservation could not have occurred through random survival. It required deliberate effort to protect and transmit critical information. The Great Pyramid at Giza encodes astronomical knowledge with precision that was not matched by modern astronomy until the development of advanced instruments. The structure's base perimeter divided by its height yields pi to several decimal places. More significantly, the ratio of the pyramid's base perimeter to its height, when multiplied by 43,200, equals Earth's polar radius to within 99.9% accuracy. The number 43,200 represents exactly 1/60th of the precessional cycle in years. This encoding demonstrates that the pyramid's builders understood both the mechanics of precession and Earth's precise dimensions. The knowledge required for such calculations demands long-term observational programs that span centuries, programs that could not have been conducted entirely in the post-flood period given conventional chronologies for pyramid construction. The knowledge must have been inherited from pre-flood sources that had conducted the necessary observations. The pyramid's internal passages align with stellar positions that would have been visible during specific precessional ages. Computer modelling reveals that the alignments were perfect approximately 10,500 BC, during a different precessional age than when conventional dating places the pyramid's construction. This earlier alignment date coincides with the Sphinx's stellar orientation and suggests the Giza complex was designed according to astronomical configurations that existed thousands of years before the structures were supposedly built. The precision of these alignments required knowledge of stellar proper motion, the gradual movement of stars across the sky over millennia. Ancient astronomers would need to account for these minute changes to create alignments that remained accurate across multiple precessional cycles. The fact that the Giza monuments incorporate such calculations indicates their builders possessed astronomical knowledge comparable to modern astrophysics. Stonehenge demonstrates similarly sophisticated understanding of precessional mechanics through multiple construction phases spanning millennia. The monument's earliest elements date to approximately 3100 BC, but its final configuration was completed around 1600 BC, suggesting continuous astronomical observation and refinement across 40 generations. The site's various stone circles and alignments track stellar positions, corresponding to distinct precessional epochs. The heel stone's alignment with the summer solstice sunrise has shifted over millennia due to precession, but computer analysis reveals the stone was positioned to maintain its astronomical function across multiple ages. The monument's builders anticipated precessional changes and incorporated adjustments that would preserve the site's celestial alignments for thousands of years. This long-term planning required mathematical models of precessional motion that were not officially discovered until Hipparchus in the 2nd century BC. The station stones at Stonehenge form a rectangle with proportions that encode the latitude of the site and the angle of Earth's axial tilt. These measurements change over precessional cycles due to the planet's wobbling motion, yet the stones are positioned to reflect average values that remain constant across the entire 25,720-year cycle. This mathematical sophistication suggests the monument's designers understood precession as a complete system rather than merely observing its effects. Angkor Wat in Cambodia represents perhaps the most sophisticated architectural encoding of precessional knowledge ever constructed. The temple complex covers more than 400 acres and contains over 1,000 buildings arranged according to astronomical principles that mirror cosmic order described in Hindu cosmology. The central temple's measurements encode multiple astronomical cycles with mathematical precision, that rivals modern calculations. The central tower stands 65 metres high, and the distance from the western entrance to the central shrine measures 1,728 metres, exactly 4 times 432, the fundamental precessional number that appears throughout ancient astronomical systems. The temple's total east-west axis spans 1,025 metres, while the north-south axis measures 802 metres, ratios that encode relationships between various astronomical cycles. Angkor Wat's bas-reliefs depict the churning of the cosmic ocean, a Hindu creation myth describing gods and demons working together to extract the elixir of immortality from primordial waters. The relief shows 92 demons on the south side and 88 gods on the north side, totaling 180 figures that represent the number of degrees in a semicircle. This astronomical symbolism continues throughout the temple, with architectural elements consistently encoding celestial mechanics and cosmic cycles. The Mayan calendar system demonstrates the most sophisticated understanding of cyclical time found in any ancient civilization, incorporating multiple interlocking cycles that track astronomical events across vast periods. The Mayan long count calendar measures time from a creation date corresponding to August 11, 3114 BC, marking the beginning of the current cosmic cycle that concluded on December 21, 2012 AD. This 5,725-year period represents exactly 1/5 of the precessional cycle, indicating Mayan awareness of the Great Year. The Mayan calendar integrates multiple concurrent cycles, including the 260-day sacred calendar, the 365-day solar year, and longer periods measuring Venus cycles, eclipses, and planetary conjunctions. The calendar round combines the sacred and solar calendars in a 52-year cycle that repeats 1,572 times during the complete long count period. These mathematical relationships demonstrate understanding of astronomical mechanics that required continuous observation spanning centuries. Mayan astronomical texts describe celestial body movements with accuracy that European astronomy did not achieve until telescopic observation. The Dresden Codex contains eclipse tables that accurately predict lunar and solar eclipses for centuries into the future, while Venus tables track the planet's synodic cycle with precision to within hours over extended periods. These calculations require mathematical knowledge comparable to modern celestial mechanics. The consistency of sophisticated astronomical knowledge across cultures separated by oceans and millennia presents the same pattern observed in flood narratives, either unprecedented coincidence of independent invention or transmission of knowledge from common sources. The mathematical precision is too similar, the astronomical constants too consistently encoded, the precessional understanding too uniformly sophisticated to easily explain as parallel development. The ancient texts provide a framework for understanding this consistency. They describe the knowledge as taught rather than discovered, transmitted by the Anunnaki in Mesopotamian accounts, by the Neteru in Egyptian traditions, by culture heroes in Mesoamerican sources. The teaching narrative appears so consistently across independent cultures that dismissing it as coincidental mythological motif requires explaining why diverse populations would independently invent identical false origin stories while simultaneously possessing the genuine advanced knowledge those stories attribute to external sources. The alternative interpretation that the knowledge was actually transmitted from sources that predate the individual civilizations displaying it accounts more coherently for both the precision of the information and the consistency of its attributed origin. But accepting this interpretation requires accepting that entities or civilizations possessing advanced astronomical knowledge existed during periods when conventional chronology places only primitive populations. The Sumerian texts identify these knowledge sources as the Anunnaki and describe their activities with specificity that continues to create chronological problems. The descriptions include not merely abstract teaching, but transfer of specific technologies, establishment of observational infrastructure, and training programs that produce generations of priests and astronomers capable of maintaining sophisticated knowledge systems. At the ancient city of Mari, tablets describe the establishment of astronomical observation facilities attributed to Anunnaki instruction. The texts reference celestial observation chambers equipped with divine measuring rods that enabled precise tracking of planetary movements and stellar positions. These descriptions suggest instrumentation rather than naked eye observation, devices that enhanced human observational capabilities beyond natural limits. Similar references appear in Egyptian texts describing the Neteru's establishment of astronomical priesthoods and the training systems that maintained observational continuity across generations. The texts describe how selected individuals were taught to operate observation equipment, perform calculations, and interpret celestial patterns. The specificity suggests institutional knowledge transfer rather than mystical revelation. The question is, what became of this infrastructure? If pre-flood civilizations possessed observational facilities sophisticated enough to generate the astronomical precision that post-flood monuments encode, where is the physical evidence of these installations? The answer may lie in the same processes that destroyed pre-flood urban centres. If observational infrastructure was concentrated in coastal regions that are now submerged, or in areas that were catastrophically disrupted during the Younger Dryas impacts, then the physical remains would be underwater, buried, or destroyed. What survived was the knowledge itself, preserved through the teaching systems the Anunnaki had established and maintained through carefully trained priestly lineages that continued post-flood. The monuments encoding astronomical precision represent not contemporary observations, but preservation of data collected over centuries or millennia by pre-flood populations and transmitted through the catastrophe by survivors who understood its significance. This framework explains why post-flood civilizations display complete knowledge systems without apparent developmental periods. They were not developing the knowledge, they were implementing it, working from preserved data, following instructions maintained through oral transmission or recovered texts, reconstructing observational programs that had been disrupted but not entirely lost. The Sumerian texts describe this reconstruction process with the same administrative precision that characterizes their pre-flood accounts. They document how the Anunnaki guided re-establishment of agricultural systems, urban centers, and knowledge infrastructure. The texts present this not as mythology, but as institutional history, records of how civilization was rebuilt under organized direction rather than random recovery. And in these reconstruction accounts, there appears a detail that shifts the question from what knowledge survived to why certain knowledge was deliberately not restored. The selective restoration appears in patterns of knowledge distribution across post-flood civilizations. Certain capabilities were widely transmitted: agricultural techniques, basic metallurgy, administrative systems for managing urban populations. Other knowledge domains remained concentrated in priestly classes, subject to strict access controls and elaborate training requirements that limited who could possess specific information. The distribution pattern suggests deliberate compartmentalization rather than random knowledge loss. The Mesopotamian temple complexes functioned as more than religious centers. archaeological evidence reveals they served as administrative hubs, astronomical observatories, knowledge repositories, and training institutions for specialized priesthoods. Access to inner chambers was restricted by architectural design, passages too narrow for general access, chambers requiring specific knowledge to navigate, systems that physically separated different levels of information. The ziggurat structures that dominated Mesopotamian cities were not merely symbolic mountains connecting earth and heaven. Their internal architecture incorporated features suggesting functional purposes beyond ritual. Acoustic chambers that amplified sound at specific frequencies. Ventilation systems that maintain precise environmental conditions. Observation platforms oriented towards specific stellar positions. The engineering suggests technological infrastructure rather than purely ceremonial construction. Similar compartmentalization appears in Egyptian temple complexes, where hieroglyphic inscriptions on inner walls differ substantially from public-facing texts. The inner sanctuary writings incorporate mathematical and astronomical notation, encoded symbolic references, and multi-layered meanings accessible only to priests who had undergone decades of specialized training. The temple hieroglyphs represent a distinct knowledge system, separate from the simplified scripts used for everyday administration. The pyramid texts inscribed in 5th Dynasty burial chambers contain passages that appear to be operational instructions rather than purely religious incantations. The texts describe procedures for accessing specific locations, include what read like passwords for passing checkpoints, and warn about dangers awaiting those lacking proper authorization. The language suggests these texts served functional purposes beyond spiritual guidance. One particularly enigmatic passage, known as the Cannibal Hymn, describes the pharaoh consuming the divine essence of the Neteru to acquire their knowledge and capabilities. The imagery is disturbing enough that many translations soften it, but the original Egyptian text is explicit about ritualistic consumption. Whether this represents metaphorical knowledge transfer or describes actual procedures for transmitting biological or technological enhancements remains debated, but the specificity suggests the latter. The genetic component of knowledge transmission appears consistently in accounts describing how certain capabilities were restricted to specific bloodlines. Royal and priestly families practiced carefully controlled marriages designed to maintain hereditary characteristics considered essential for communication with divine authorities. The practice was not merely cultural tradition, but represented biological requirements for accessing certain knowledge systems or technologies. Egyptian pharaohs practiced brother-sister marriage, despite obvious genetic risks. The biological consequences included high rates of congenital disorders that plagued royal lineages, yet the practice continued for millennia. The persistence suggests that maintaining specific genetic markers took priority over health concerns, that certain hereditary traits enabled interactions or capabilities that outweighed the medical costs. Mesopotamian cuneiform texts specify that certain priestly positions could only be held by individuals descending from particular bloodlines. These were not honorary hereditary titles, but technical qualifications. The tablets indicate that specific families maintained knowledge necessary for operating temple systems, and this knowledge was transmitted through genetic channels as much as through training. The texts suggest that certain individuals possessed physiological characteristics, enabling them to interface with technologies inaccessible to ordinary humans. The tablets of destinies, described as devices granting control over natural forces, apparently required biometric authentication. They would respond only to operators whose genetic markers matched authorization protocols. The Epic of Ansu provides the most detailed account of these tablets. The text describes them as objects that granted their possessor control over natural forces and the ability to issue binding decrees affecting both divine and human realms. But the tablets did not function for just anyone who possessed them. When the bird demon Anzu stole the tablets, chaos resulted not because he gained control, but because the devices recognized unauthorized access and failed to function properly. The formal authority transfer ceremonies described in Mesopotamian texts involved physical contact between the tablets and designated human recipients. Archaeological evidence from the Mari throne room suggests these ceremonies produced measurable energy discharge. The chamber contains a raised platform with metallic inlays arranged in geometric patterns, and the platform shows signs of intense heat exposure, scorch marks indicating energy discharge of considerable magnitude with no conventional explanation. The heat damage patterns suggest the ceremonies involved more than symbolic ritual. Something physical occurred during these authority transfers, possibly the activation of latent genetic modifications, possibly the imprinting of command authorization into nervous systems that had been engineered with receiver capabilities. The specificity of the archaeological evidence supports the text's descriptions of actual technological processes rather than purely ceremonial performances. Modern genetic research has identified anomalous DNA sequences in certain human populations that appear to have no clear evolutionary pathway. These sequences are most prevalent in populations descended from ancient Near Eastern regions, precisely the areas where the texts describe genetic modification programs. The correlation suggests possible hereditary continuity from bloodlines that ancient accounts describe as having been modified for specific purposes. If the texts document actual genetic engineering programs, then certain human lineages were deliberately designed to serve as interfaces between the Anunnaki and general human populations. These modified individuals would possess capabilities that ordinary humans lacked: enhanced cognitive function, extended lifespan, or biological mechanisms enabling them to perceive or interact with technologies invisible to others. The cuneiform text indicates these enhanced bloodlines were concentrated in specific geographical regions: northern territories under Anu's authority, central plains under Enlil's control, southern regions governed by Enki. Each maintained separate populations with distinct genetic characteristics suited to particular administrative functions. Over time, these populations mixed, and the genetic boundaries broke down through migration, conquest, and unauthorized reproduction. The text described this genetic mixing as a recurring problem requiring periodic intervention to correct. The flood represented the most extreme correction, a complete reset that eliminated corrupted bloodlines and re-established controlled populations from preserved genetic samples. But the mixing continued in the post-flood period, requiring ongoing efforts to maintain bloodline purity in royal families while the general population became increasingly hybridized. The result was gradual dilution of enhanced characteristics, a slow drift toward genetic configurations that no longer matched original design specifications. The Watchers responded by withdrawing further from direct human contact. Texts from later periods describe fewer face-to-face encounters, more mediated communications, longer intervals between interventions. The impression is of a management system struggling to maintain control over populations drifting outside the parameters that the system was designed to govern. By the first millennium BC, cuneiform texts describe the Anunnaki as having largely ceased direct involvement in human affairs. Priestly classes continued performing rituals, maintaining communication protocols, and preserving knowledge systems. But responses from the Anunnaki became less frequent and less specific. The texts shift to past tense when describing these entities, speaking of what they did during earlier ages, rather than what they currently do. This shift coincides with changes in the archaeological record. The great ziggurat construction programs ended. Massive irrigation projects requiring coordination across vast territories became localized. Astronomical observation programs that had produced increasingly precise calculations plateaued, then gradually declined as knowledge keepers died without replacing their expertise. The cuneiform tradition itself began to fade as fewer scribes trained in ancient languages and fewer tablets were produced. But certain installations apparently remained active. Texts from the Seleucid period, the final centuries of cuneiform writing before it, disappeared entirely, still reference underground chambers requiring restricted access and mountain sanctuaries where unauthorized approach resulted in documented consequences. The enforcement mechanisms continued functioning even as broader communication systems fell silent. The question is whether this silence represented actual departure or merely cessation of communication. The texts are ambiguous, describing the Anunnaki as having departed to their own place, while also indicating that underground installations remained operational, mountain sanctuaries continued being maintained, and forbidden territories were still enforced. The Hebrew prophetic literature from the same period describes divine beings in terms suggesting physical presence rather than abstract spiritual entities. Ezekiel's vision recorded during the Babylonian exile describes craft with rotating wheels, beings with multiple faces, structures with crystalline appearance and metallic components. The language struggles to describe what Ezekiel witnessed, reaching for comparisons like burnished bronze, like glowing metal, like sapphire, that suggest advanced technology rendered in vocabulary designed for Bronze Age material culture. The Book of Daniel describes encounters with beings called Watchers, using terminology that traces directly back to the Akkadian EGI. These Watchers issue decrees affecting earthly kingdoms, suggesting continued administrative authority over human political structures. The text does not present them as distant or abstract. They appear, deliver messages, and depart, operating with the efficiency of officials executing predetermined protocols. The Dead Sea Scrolls preserve additional texts excluded from standard biblical canon. The Book of Giants describes the Nephilim, offspring of the Watchers, as possessing knowledge, allowing them to perceive reality's true nature. The text says these beings had disturbing dreams in which they saw coming destruction and understood that their existence violated protocols that could not be permanently evaded. The scrolls also preserve Enochic literature fragments describing the underground imprisonment of rebellious Watchers in geographic detail. The texts specify locations: valleys near the Dead Sea, chambers beneath mountain ranges east of Babylon, sealed installations in northern regions near the Caucasus. These are not mythological underworlds, but geographical coordinates. Archaeological surveys of some regions have revealed anomalies. Ground-penetrating radar has detected large void spaces beneath areas where no known excavation occurred. Seismic studies show cavities at depths exceeding documented ancient mining operations. The geological explanations for these voids are uncertain. Natural cave formations in regions where rock layers typically don't produce caves, erosion patterns that don't match water flow, structural features suggesting artificial excavation. Access to these sites is often restricted. Some lie in military zones. Others occupy politically sensitive territories where archaeological investigation is unwelcome. A few have been explored unofficially, producing difficult-to-verify accounts describing sealed passages, metallic surfaces that don't corrode, chambers with artificial lighting having no apparent power source. These accounts exist at archaeology's margins, dismissed by mainstream researchers as misidentifications or fabrications, but they persist. Multiple independent reports from different periods describing similar features in locations corresponding to ancient texts. The pattern suggests the possibility that underground installations described in cuneiform and Hebrew sources remain physically intact. The ancient texts indicate that imprisoned watchers were bound for specific durations, periods measured in generations or cosmic cycles that would eventually expire. The Book of Enoch describes their punishment as lasting until final judgment, but other texts suggest shorter terms. Mesopotamian sources describe banishment periods ending when certain astronomical conditions recurred, when particular stellar configurations returned, when specific planetary alignments repeated. These astronomical cycles operate on timescales dwarfing human historical memory. The precessional cycle completes every 25,220 years. Mesopotamian astronomical texts track this precession with precision, suggesting they understood its implications. The changing celestial pole position, the slow stellar drift, the long-term patterns invisible to civilizations observing for mere centuries. If the Watcher's imprisonment or withdrawal was keyed to such cycles, their return would occur on schedules bearing no relationship to human calendars. The ancient texts might describe events separated from our era by time spans so vast that entire recorded history represents merely an interim period, a pause between active phases of whatever program the Watchers were administering. The mathematical knowledge preserved in ancient sources supports this long cycle interpretation. The Mayan calendar tracks multiple overlapping cycles, including a long count spanning 5,625 years, but Mayan texts also describe longer cycles, a great cycle of 26,000 years corresponding precisely to the precessional period that Mesopotamian astronomers calculated. Two civilizations separated by oceans and millennia, both tracking the same astronomical cycle with identical mathematical precision. The independent discovery explanation becomes strained when calculations match to multiple decimal places. The precision suggests either shared observational data or transmission from common sources that possessed long-term astronomical records spanning complete precessional cycles. The question is what that shared source was and whether it still exists in some form. Whether the silence that has persisted since classical antiquity represents true absence or merely non-communication. Whether the systems described in ancient texts as monitoring human development have ceased functioning or continue operating according to protocols we no longer understand. And there is something in the patterns of our current technological development that echoes descriptions in ancient texts of capabilities that triggered previous interventions. The technological parallels appear with enough specificity to create a particular kind of unease. The ancient texts describe pre-flood civilizations possessing capabilities that the Anunnaki considered dangerous when concentrated in human hands without adequate oversight. The specific categories of knowledge that Enochic tradition identifies as forbidden teachings correspond closely to technological domains that define modern civilization: metallurgy, genetic manipulation, astronomical prediction, and what the texts call the resolving of enchantments, which may represent advanced understanding of natural forces. The Book of Enoch catalogues the forbidden knowledge with precision that suggests these were actual categories of restricted information rather than symbolic representations of human overreach. Azazel taught metallurgy and weapon making, instructing humans in mining or purification and alloy creation. Shemyaza taught enchantments and root cutting, activities that may represent genetic manipulation and pharmaceutical knowledge. Barakel taught astronomy and celestial observation. Each watcher had a specific domain of expertise that was transmitted to humans despite prohibitions against such teaching. The texts frame this knowledge transfer as transgression, violation of boundaries that existed for purposes the watchers understood but chose to ignore. The resulting situation, according to these accounts, produced populations possessing capabilities they lacked the wisdom to manage responsibly. The flood was implemented not as punishment for moral failure, but as correction of a control problem. Humans had acquired abilities that threatened the stability of whatever larger program their civilization was embedded within. Modern technological development has reached or exceeded several thresholds that ancient texts identify as significant. Genetic engineering capabilities now enable modification of human DNA with precision that would have seemed miraculous decades ago. CRISPR and related technologies allow editing of genetic code with accuracy that approaches the modifications the Sumerian texts attribute to Anunnaki intervention. We possess the technical means to alter human heredity in ways that would persist across generations. The ethical frameworks governing these capabilities remain contested and incomplete. International agreements attempt to restrict germline editing, but enforcement mechanisms are weak and technological access is spreading. The capability exists, and the temptation to use it for enhancement rather than merely therapeutic purposes grows as the technology becomes more accessible and precise. We are approaching the threshold where human genetic modification becomes practical reality rather than theoretical possibility. Artificial intelligence development represents another domain that ancient texts might categorize as forbidden knowledge. The creation of non-human intelligences parallels the Watcher's creation of humans, raising questions about whether we possess adequate wisdom to responsibly manage beings we create. The texts emphasize that the Anunnaki carefully controlled human capabilities, imposing limitations designed to prevent humans from exceeding their designated parameters. Our AI development proceeds without comparable constraint mechanisms. The rapid advancement of machine intelligence systems has produced capabilities that exceed human performance in increasingly complex domains. Pattern recognition, strategic planning, natural language processing, areas that were supposed to represent uniquely human cognition, are being matched or surpassed by artificial systems. The trajectory suggests that artificial general intelligence, systems capable of learning and reasoning across any domain humans can, may emerge within decades rather than centuries. The control problem with advanced AI mirrors concerns the ancient texts express about human enhancement. Once created, can such entities be reliably confined to intended purposes? Will they remain manageable by their creators, or will they develop autonomous goals that conflict with human interests? The ancient texts suggest the Anunnaki faced similar questions about humans and implemented the flood when the answer became clear that control was failing. Space exploration represents a third threshold domain. The ancient texts describe the Anunnaki as those who from heaven to earth came, suggesting they arrived from elsewhere and established operations on Earth. Human expansion into space could represent either successful graduation from managed status, demonstrating capability to operate beyond Earth-based control systems, or premature breakout that triggers corrective intervention. The establishment of permanent human populations beyond Earth's surface would fundamentally alter whatever monitoring or management systems the ancient texts describe. If those systems were designed for Earth-based populations, then off-world colonies could escape their jurisdiction. The ancient texts indicate that the Anunnaki carefully maintained boundaries. specific territories were designated for human habitation, while other areas remained restricted. Human space colonization would violate those boundaries at a fundamental level. Current technological capabilities approach several other thresholds the ancient texts might categorize as significant. Nanotechnology provides means for manipulating matter at molecular scales. Quantum computing may enable calculations that were previously impossible. Biotechnology allows creation of synthetic organisms with designed characteristics. Each capability individually represents powerful technology. Collectively, they approach the kind of comprehensive control over physical reality that the texts attribute to the Anunnaki themselves. The pattern that emerges is uncomfortable. We are developing capabilities across multiple domains that ancient texts identify as restricted knowledge, abilities that previous civilizations were prevented from accessing, or that triggered corrective interventions when boundaries were exceeded. Whether this represents coincidental similarity between modern technology and ancient mythology, or whether we are actually approaching thresholds that monitoring systems were designed to detect, cannot be determined without accepting that those monitoring systems exist. The ancient texts provide a framework for understanding why certain capabilities might require restriction. The concern is not that technologies are inherently dangerous, but that they enable actions whose consequences extend beyond what those using them can predict or control. Genetic modification affects not merely current populations, but all subsequent generations. Artificial intelligence, once created, cannot be reliably contained or eliminated. Space colonization, once begun, cannot be recalled if it produces undesired outcomes. The texts emphasize that the Anunnaki possess these same capabilities, but exercise them within frameworks that incorporated long-term consequence assessment and collective decision-making. The suggestion is that powerful technologies require not merely technical capability, but institutional structures, ensuring that their use aligns with understanding of larger-scale implications. Pre-flood humans apparently lacked such structures, leading to uses of technology that produced catastrophic results. Modern civilization faces similar challenges. Our technological capabilities advance faster than our institutional capacity to manage them. International organizations attempt coordination, but enforcement mechanisms remain weak and participation is voluntary. Individual researchers, corporations, or nations can pursue technological development with limited oversight and minimal consideration of global consequences. The structure resembles what the texts describe as producing pre-flood instability. The question the ancient texts raise is whether this pattern triggers automatic responses from monitoring systems, or whether it represents a test of human developmental maturity, whether we are expected to self-regulate, to demonstrate wisdom by choosing not to pursue certain capabilities even when technically feasible, or whether external limitation will be imposed if we exceed boundaries. The texts suggest both mechanisms existed simultaneously. Automatic systems maintained basic controls and prevented certain categories of violation, while conscious oversight evaluated broader developmental patterns and made decisions about guidance versus intervention. If this dual system remains operational, then humanity faces both automatic constraints we cannot perceive and evaluative observation by intelligences whose criteria we do not understand. The absence of obvious intervention could indicate several possibilities. We may not have crossed critical thresholds yet, despite approaching them. The evaluation may still be in progress, with decision makers waiting to see whether we develop adequate wisdom before capabilities exceed safe limits, or the decision may have been made to allow us to proceed without interference, to determine whether we can successfully navigate challenges through our own development. the Sumerian texts describe ongoing debate among the Anunnaki about appropriate treatment of humanity. Enki advocated for protective guidance and gradual knowledge transfer. Enlil argued for strict limitations and natural consequences when boundaries were exceeded. The post-flood compromise apparently involved reduced direct intervention, while maintaining monitoring and reserve capacity for corrective action if development exceeded acceptable bounds. This framework would produce exactly the pattern observed: long periods of apparent absence, interrupted by occasional contacts during critical junctures. The modern era, with its exponential technological growth and global connectivity, represents precisely the kind of critical juncture the texts describe as requiring evaluation. We approach capabilities that could fundamentally alter the human condition: genetic modification of our species, creation of non-human intelligences, expansion beyond Earth's surface. Each development crosses boundaries that ancient texts describe as significant thresholds. Unauthorized genetic manipulation triggered the flood. Creation of beings that exceeded their creator's control produced the Nephilim problem. Expansion beyond designated territories violated spatial restrictions the Anunnaki carefully maintained. Our current trajectory touches all three categories simultaneously. If monitoring systems exist and track these developments, then our choices during the next several decades may determine whether we receive autonomy, continued guidance, or corrective intervention. The ancient texts indicate that such determinations are not made precipitously, that extended observation precedes intervention, and that preference exists for allowing civilizations to develop through their own struggles, rather than imposing solutions that prevent genuine learning. But the texts also describe thresholds beyond which observation becomes insufficient, points where civilization's trajectory clearly leads toward outcomes that would damage not merely the human population, but larger systems within which humanity is embedded. The flood was implemented when pre-flood development threatened cosmic order, when violations of boundaries separating different domains of reality could not be corrected through guidance alone. Modern technological development may approach similar thresholds: genetic modifications that make humans unrecognizable to management systems designed for natural human genomes, artificial intelligences that establish autonomous presence in infrastructure designed for organic control, space colonies that propagate uncontrolled human development beyond the reach of Earth-based monitoring. Each represents potential breakout scenario, development that would force intervention or acceptance that human civilization has escaped constraints. The ancient texts hint that eventually successful breakout might be permitted if demonstrated capability warranted it, that the management program may have included graduation conditions allowing autonomous operation once sufficient maturity was achieved. But they also emphasize that premature breakout attempts, breaking free before achieving necessary wisdom, ended with corrective interventions that reset development to earlier stages. The ambiguity leaves unclear whether our current approach to threshold technologies represents appropriate ambition that will earn autonomy or premature recklessness that will trigger intervention. The answer may depend less on the technologies themselves than on the wisdom we demonstrate in their development and deployment. The texts emphasize that context and intention matter to evaluation, that identical capabilities might be judged differently depending on why they were developed and what purposes they serve. If monitoring systems exist and assess not merely what we do, but why we do it, then humanity's performance is evaluated through both our technological achievements and the purposes those achievements serve, not only through our knowledge accumulation, but through the wisdom we apply that knowledge with, not only through our capabilities, but through the restraint we exercise in their use. The ancient texts describe the Watchers as having possessed overwhelming technological capabilities, but choosing to exercise them within constraints established by their understanding of proper order. They could have dominated humanity completely, but operated through influence and guidance. They could have prevented all suffering, but allowed natural consequences to teach lessons. They could have revealed all knowledge immediately, but disclosed it gradually as humans demonstrated readiness. This combination of power and restraint represents, according to the texts, the model mature civilizations should emulate, the demonstration that capability does not require utilization. That wisdom includes knowing when not to act despite ability to do so. That proper exercise of power involves respecting boundaries and accepting limitations even when physical capability could override them, whether humanity has developed. This kind of wisdom remains the question these ancient accounts seem designed to raise. Our history shows repeated patterns of capability being used simply because it existed, boundaries violated because enforcement was absent, power exercised without adequate consideration of consequences. But our history also shows increasing sophistication in ethical reasoning, growing recognition of interconnection and responsibility, emerging frameworks for collective decision-making. The evaluation apparently continues. The outcome remains undetermined, and the question sitting quietly beneath all technical analysis is whether we are being observed at all, or whether these patterns represent nothing more than ancient attempts to make sense of mysteries that remain mysterious. The observational question cannot be answered through archaeological evidence alone, because the nature of observation systems described in ancient texts would not necessarily leave detectable traces. The Sumerian accounts describe monitoring capabilities that operated through means we lack vocabulary to properly categorize, technologies that sound like supernatural abilities when rendered in Bronze Age terminology, but that might represent advanced sensor networks or data collection systems when translated into modern conceptual frameworks. The cuneiform texts describe the Anunnaki as possessing the ability to see across the waters of time, to perceive events before they occurred, and to observe multiple locations simultaneously. These capabilities, presented in ancient sources as divine attributes, might represent access to predictive modelling systems or surveillance networks rather than mystical omniscience. The distinction between sufficiently advanced technology and magic becomes meaningful when examining whether the texts describe actual capabilities or merely mythological imagination. The consistency of observation-related descriptions across independent ancient sources suggests these accounts may preserve memories of actual monitoring systems rather than merely expressing universal human tendency to imagine divine oversight. The Mesopotamian EGE, the Hebrew ear, the Egyptian concepts of cosmic order maintained through constant observation, these appear in cultures with distinct linguistic roots and different theological frameworks, yet they describe remarkably similar monitoring functions. The linguistic evolution traces actual transmission patterns rather than independent invention. The Hebrew IR derives from Aramaic roots, traceable to Akkadian IGI, indicating conceptual continuity spanning millennia and multiple language families. This continuity suggests the monitoring concept was preserved through cultural transmission rather than independently imagined, that subsequent cultures inherited rather than invented the idea of divine observers tracking human activities. Archaeological evidence of installation sites that could have housed monitoring infrastructure appears in locations the texts identify as watcher facilities. Mount Hermon, repeatedly described as a primary descent point an operational centre for the Watchers, contains extensive ancient construction that predates known historical settlements. The summit features megalithic structures with foundation stones weighing over 20 tons, fitted with precision requiring advanced engineering capabilities. The temple complex ruins on Mount Hermon are oriented toward astronomical positions significant in Mesopotamian celestial observations. The coordination between this site and Mesopotamian astronomical facilities suggests networked operations rather than isolated local religious activity. If the mountain served as regional monitoring node in a distributed observation network, then the astronomical alignments may represent targeting mechanisms or communication protocols rather than merely ceremonial orientation. Similar installations appear at other locations the texts identify as Watcher sites. The Caucasus mountain regions, described in ancient sources as territories that remained under Anunnaki authority after the flood, contain prehistoric megalithic structures showing construction techniques comparable to those found at recognized ancient engineering sites. These high-altitude installations would provide extensive visibility across surrounding territories, ideal locations for observational facilities. Underground chamber complexes beneath ancient cities present another category of potential monitoring infrastructure. The installations beneath Nippur extend far deeper than religious purposes require and incorporate ventilation systems maintaining air circulation for millennia without apparent power sources. The engineering suggests these chambers were designed for long-term occupation or operation rather than merely ceremonial use. The carved reliefs on chamber walls depict what appear to be instrumentation panels, surfaces with measurement markings, conduits connecting components, control interfaces. The imagery is too specific to be purely decorative. If these reliefs document actual equipment that once occupied the chambers, then they provide visual records of technologies whose purposes we can no longer identify. Similar underground installations beneath Egyptian sites show comparable characteristics. The chambers discovered beneath the Giza plateau contain granite blocks fitted with tolerances measured in fractions of millimetres, precision that suggests the chambers housed sensitive equipment requiring stable environmental conditions. The construction techniques exceed what conventional religious architecture demands, implying functional purposes beyond ritual use. The question is whether these installations remain operational or whether they represent abandoned infrastructure from management systems that are no longer active. The ancient texts provide ambiguous answers. Some passages suggest the Anunnaki departed entirely, while others indicate continued presence in concealed locations. The ambiguity may be intentional, designed to leave uncertain whether absence is actual or merely apparent. The enforcement mechanisms that reportedly continue protecting forbidden territories suggest that at least some automated systems remain functional. Accounts from various periods describe consequences of unauthorized approach to restricted sites, illnesses, equipment malfunctions, psychological effects that discourage further investigation. Whether these effects result from active defense systems, environmental hazards at remote locations, or psychological responses to transgressing culturally forbidden boundaries cannot be definitively determined, but the consistency of such accounts across centuries suggests something produces measurable deterrent effects at sites the ancient texts identify as restricted, if automated defense protocols were implemented and designed for long-term autonomous operation. They could continue functioning millennia after their original programmers ceased active involvement. The technology need not be maintained if it was designed for self-regulation across timescales that dwarf human historical periods. The ancient texts describe systems designed to operate for vast durations. monitoring protocols keyed to astronomical cycles spanning thousands of years, containment systems built to last for precessional ages, knowledge preservation mechanisms intended to survive civilizational collapses. If such systems were actually implemented, their operational persistence across millennia would not indicate continued active oversight, but merely that they were engineered for exactly this kind of long-term autonomous function. Modern automated systems provide conceptual frameworks for understanding how ancient monitoring networks could continue operating without ongoing intervention. Satellite systems orbit for decades with minimal maintenance. Deep space probes function for years on embedded programming. Data collection networks operate autonomously according to predetermined protocols. The concept of self-regulating systems maintaining functionality across extended periods is technologically comprehensible, even if the specific mechanisms the ancient texts describe remain unclear. The astronomical timing mechanisms appear throughout ancient descriptions of divine activities. The texts consistently link significant events to specific celestial configurations, suggesting that if automated systems exist, they may be keyed to astronomical conditions that recur on predictable schedules. The precessional cycle, planetary conjunction patterns, eclipse sequences, these provide reliable timing mechanisms that require no external coordination once properly programmed. If the watcher's withdrawal or imprisonment was scheduled according to astronomical cycles, then their return or release would occur automatically when specified configurations recur. The ancient texts describing beings bound until the appointed time may document actual temporal locks keyed to celestial mechanics, rather than merely expressing hope for eventual divine intervention. The specificity with which some texts describe astronomical conditions for significant events suggests technical timing mechanisms rather than symbolic associations. The Mayan long count calendar's correlation with precessional cycles indicates this kind of astronomical timing was understood and implemented by ancient civilizations. The calendar tracks not merely human historical periods, but cosmic cycles that repeat on timescales exceeding any individual culture's existence. The precision suggests the calendar preserves knowledge from sources that observed across complete precessional cycles, sources that possess data spanning 26,000 years of continuous astronomical observation. No known human civilization has maintained continuous observational programs for such durations. The longest documented astronomical traditions span perhaps 3 millennia before records become fragmentary, or traditions are disrupted by civilizational collapse. Yet the ancient calendars encode calculations requiring data from complete precessional cycles. The knowledge must have been inherited from sources that either possessed extraordinarily long institutional continuity or that had technological means for accelerating data collection. The ancient texts attribute this long cycle knowledge to the Anunnaki, describing how they taught humans to track celestial mechanics across vast periods and to recognize patterns that only become apparent when observed at precessional timescales. The teaching was supposedly intentional, designed to enable humans to calculate when significant astronomical events would recur, and therefore when systems keyed to those events might activate. This creates an interesting possibility. If monitoring or containment systems exist and are keyed to astronomical conditions, and if humans were deliberately taught to calculate when those conditions recur, then we have been provided with tools for predicting when ancient systems might become active. The knowledge preservation may represent not merely cultural transmission, but operational information, instructions for anticipating when dormant technologies might engage. The current astronomical era presents several configurations that ancient texts mark as significant. We are transitioning between precessional ages from Pisces to Aquarius, a boundary period the texts associate with disruption and transformation. Multiple rare planetary alignments occur during the coming decades. Eclipse patterns repeat on century-scale cycles that are approaching completion. If ancient systems were programmed to activate during these configurations, then the next several decades represent a predicted window. Whether anything actually occurs during these astronomical events depends entirely on whether the monitoring systems the texts describe exist and remain operational. The alternative possibility is that ancient peoples encoded astronomical knowledge into religious frameworks, because celestial patterns provided reliable calendrical systems, and that the associations between astronomical events and divine activities represent cultural meaning making rather than documentation of actual technological timing mechanisms. The conventional explanation has substantial support. Many societies have used astronomical events to structure calendars and religious observances without implying the existence of monitoring systems. The human tendency to perceive patterns and assign significance to celestial phenomena is well documented. The ancient texts could represent this universal pattern rather than descriptions of actual technologies. But the conventional explanation struggles to account for certain details. The mathematical precision of astronomical calculations in texts predating the observational capabilities those calculations require, the consistency of monitoring narratives across independent cultures using different linguistic frameworks, the physical evidence of underground installations and megalithic structures at locations the texts identify as watcher facilities, the anomalous genetic markers in populations the texts describe as having been modified. Each anomaly individually admits conventional explanation through special circumstances, but the cumulative pattern becomes progressively more difficult to dismiss. The evidence does not prove the ancient text's technological interpretation, but it makes that interpretation plausible enough to warrant consideration rather than automatic dismissal as primitive mythology. The question facing modern civilization is whether to take the ancient warning seriously, to consider that our technological trajectory may be monitored by systems whose existence we cannot confirm and whose responses we cannot predict. The texts suggest that previous civilizations faced similar choices, and that some chose to ignore warnings about boundaries, leading to catastrophic corrections. The alternative is to proceed with technological development according to our own judgment, accepting that if monitoring systems exist and we cross thresholds that trigger responses, we will discover that fact through experiencing the consequences, rather than through heeding ancient accounts we cannot verify. The texts emphasize that this choice itself may be part of the evaluation, that mature civilizations demonstrate wisdom through appropriate caution, exercising restraint when facing capabilities whose consequences exceed their ability to predict or control. That proceeding without caution, when warned, indicates developmental immaturity regardless of technical sophistication. But exercising caution based on ancient texts requires believing those texts document actual systems rather than merely mythological concerns. And that belief requires accepting that human civilization developed under conditions fundamentally different from what conventional history describes. That we are not autonomous but managed, not independent but observed. Not the sole intelligence is shaping our trajectory, but participants in programs we did not design and do not fully understand. The implications destabilize foundational assumptions about human nature, historical development, and cosmic significance. Yet discomfort with implications does not constitute evidence against accuracy. The question is not whether conclusions are comfortable, but whether they account for available information better than alternatives. and in the patterns of evidence, the precision of ancient astronomical knowledge, the consistency of monitoring narratives, the archaeological anomalies at sites the text identify as significant, there remains something that does not quite resolve into either proven fact or dismissible fiction. The resolution problem appears in every attempt to definitively categorize the ancient evidence. The archaeological sites exist, the megalithic structures at Mount Hermon, the underground chambers beneath Mesopotamian cities, the precisely fitted stones at Giza. These are measurable physical realities, documented with photographs, surveys, and excavation reports. But their interpretation remains contested because the purposes they served are no longer apparent from the structures alone. A chamber carved into bedrock with precise dimensions could be a tomb, a storage facility, a ritual space, or housing for equipment whose nature we no longer recognize. The structure itself does not declare its function. We infer purpose from context, from associated artifacts, from comparative analysis with similar structures, from textual descriptions that might reference the site. But when the texts describe functions that seem technologically impossible for the construction period, we face interpretive choices about which evidence to prioritize. The conventional approach privileges physical evidence over textual claims when they conflict. If texts describe capabilities that archaeological evidence suggests were unavailable, then the texts are treated as mythological rather than the archaeology being reconsidered. This methodology maintains chronological coherence at the cost of requiring increasingly elaborate explanations for why ancient peoples would consistently describe specific technologies they supposedly never witnessed. The alternative approach takes textual descriptions more literally and asks whether physical evidence might support technological interpretations that conventional dating excludes. This methodology potentially accounts for anomalous precision and sophisticated knowledge in ancient contexts, but requires accepting that current chronological frameworks may be incomplete or that knowledge transmission occurred through means not yet accounted for in mainstream archaeology. Neither approach can claim definitive validation because the evidence remains incomplete. The underwater archaeological sites that might provide conclusive data are largely unexplored due to technical, political, or financial constraints. The underground installations that texts identify as primary watcher facilities are often inaccessible due to their locations in restricted territories. The genetic evidence that might confirm or refute modification claims requires analysis of ancient DNA samples that are difficult to obtain and subject to contamination issues. The gaps in evidence create space for legitimate disagreement about interpretation. Scholars examining identical data reach different conclusions depending on which anomalies they consider most significant and which explanatory frameworks they find most compelling. The debate continues not because evidence is absent, but because available evidence admits multiple interpretations that cannot be conclusively distinguished without access to additional data. The Sumerian texts themselves seem aware of this ambiguity. Certain passages appear designed to preserve information in forms that would remain meaningful across multiple interpretive frameworks, encoding astronomical data in mythological narratives, embedding mathematical constants in architectural proportions, documenting technical knowledge through ritual procedures that could be performed without full comprehension of underlying principles. This multi-layered encoding suggests intentional design for knowledge preservation across civilizational disruptions. Information structured to survive through cultures that might lose technical understanding while maintaining ritual practices. Knowledge embedded in forms that would motivate preservation, even when operational significance was forgotten. The methodology would ensure transmission to future civilizations that developed capability to recognize and extract the embedded technical content. If this interpretation is accurate, then we may be reaching the stage where extraction becomes possible. Modern knowledge of genetics, astronomical mechanics, and information systems provides conceptual frameworks for recognizing technical content that earlier readers could not perceive. What previous generations read as supernatural mythology, we can potentially interpret as descriptions of advanced technologies rendered in prescientific vocabulary. But this reinterpretation carries risks. The tendency to see technology in every ancient account can produce over-interpretation, finding technical meanings that were never intended, imposing modern frameworks on materials that were genuinely mythological, mistaking cultural metaphors for physical descriptions. The balance between recognizing actual technical content and projecting contemporary concerns onto ancient texts remains difficult to maintain. The ancient texts do not resolve this ambiguity. They employ language that admits both technical and spiritual interpretation. They describe events that could represent either advanced technology or divine intervention, depending on framework. They preserve information that remains meaningful across interpretive approaches, functioning simultaneously as religious literature, historical documentation, and potential technical manuals. This flexibility may be intentional, knowledge encoded in ways allowing multiple valid interpretations serves audiences at different developmental stages. Earlier civilizations extracted spiritual meaning sufficient to motivate preservation. Later civilizations might extract technical content once they developed capability to recognize it. The same text serves both purposes without losing coherence in either framework. If the Watchers designed knowledge transmission systems to function across millennia, incorporating this kind of interpretive flexibility would be essential. Information would need to remain culturally valuable even when technical significance was not understood, ensuring preservation until future civilizations developed capability to extract embedded operational content. Whether the ancient texts represent such design transmission systems or merely accidental preservation of interesting narratives cannot be definitively determined from available evidence, but the patterns suggest intentionality. Information structured in ways that maximize survival and accessibility to future audiences, while minimizing immediate disruption to societies not yet ready for full revelation. We inherit this carefully preserved information at a moment when our capability to interpret it technically has reached unprecedented levels. Our knowledge of genetics allows recognition of modification programs described in creation accounts. Our understanding of astronomy enables identification of sophisticated calculations encoded in ancient monuments. Our technological development provides frameworks for recognizing advanced capabilities described in contact narratives. The convergence of preserved information and interpretive capability may represent either coincidence or design. If coincidence, then we are fortunate that texts survived long enough for us to potentially understand them. If design, then the timing suggests we approach thresholds the original preservers considered significant, moments when knowledge becomes accessible because development has reached stages where its revelation serves purposes the preservation systems were designed to accomplish. The ancient texts describe such thresholds as decision points, times when civilizations must choose directions determining ultimate trajectories, when capabilities reach levels enabling either transcendence or catastrophe, when wisdom becomes not merely valuable but necessary for survival. Whether we have reached such a threshold cannot be determined with certainty, but the question is at least worth asking. The ancient accounts may preserve not merely interesting stories, but essential warnings. The knowledge encoded in texts from Sumer, Egypt and Hebrew tradition may speak to our situation more directly than we have recognised. The Watchers, if they existed, established systems designed to operate across vast timescales, monitoring networks that would continue functioning for millennia, knowledge preservation mechanisms that would survive civilizational collapses, evaluation protocols that would assess human development against long-term criteria. These systems, if real, would still be operating, still monitoring, still evaluating, and somewhere, in underground chambers or mountain installations or locations we lack frameworks to properly conceptualize, the assessment continues if it exists at all. Data accumulates if there are systems to record it. Patterns are analysed if there are intelligences to interpret them. Decisions approach about what humanity has become and what we might be allowed to become if the ancient accounts describe actual rather than imagined oversight. The alternative possibility remains that there is nothing, no systems, no monitoring, no evaluation, only ancient attempts to explain their world through stories that happen to persist, accumulating significance through age rather than through accuracy. Only us alone, autonomous, unobserved, making choices whose consequences affect only ourselves and the planet we inhabit. The texts cannot tell us which interpretation is correct. They preserve accounts and maintain questions, but provide no definitive proof of actual monitoring systems. The silence that has persisted since classical antiquity offers no clarification. The Watchers, if they exist, remain concealed. The systems, if operational, continue functioning without revealing themselves to populations that no longer possess clear frameworks for recognizing their operation. We are left with uncertainty and with evidence that suggests but does not prove, with texts that describe but do not demonstrate, with patterns that intrigue but do not compel, with questions that remain open long after they were first asked in languages we can barely reconstruct from clay tablets buried beneath ruins of cities whose builders claimed they did not build alone. The archaeological evidence continues accumulating. New underwater sites are discovered showing urban complexity in periods when such development supposedly did not exist. Advanced dating techniques push back timelines for sophisticated construction and knowledge systems. Genetic analysis reveals population movements and relationships that complicate conventional migration narratives. Each discovery adds detail to pictures that remain frustratingly incomplete. The textual evidence continues being re-examined. Improved translations reveal nuances in ancient languages that earlier interpretations missed. Comparative analysis identifies connections between independent traditions that suggest information transmission through means not yet fully mapped. Linguistic studies trace conceptual evolution, showing how technical terminology might have been transformed through cultural transmission into religious vocabulary. But despite accumulating evidence and improving analytical techniques, the fundamental questions remain unresolved. Did advanced civilizations exist before currently recognized historical periods? Did non-human intelligences interact with early human populations? Were knowledge systems transmitted from external sources rather than independently invented? Do monitoring or management systems continue operating according to protocols established in antiquity? The questions persist because evidence remains insufficient for definitive conclusions. The underwater sites are tantalizing but limited in scope. The underground chambers are suggestive but inaccessible for comprehensive study. The textual accounts are detailed but open to multiple interpretations. The genetic anomalies are interesting but explainable through various mechanisms. Each piece of evidence can be explained conventionally if treated in isolation. The cumulative pattern becomes more difficult to dismiss, but still falls short of proof. We are left in the uncomfortable position of having enough information to recognise significant questions, but insufficient data to answer them definitively. This may be exactly where we are meant to be at this stage of development. If knowledge revelation follows graduated protocols, with information becoming accessible as civilizations demonstrate capacity to handle it, then our current state of informed uncertainty might represent appropriate positioning. We have developed enough capability to recognize that ancient texts might describe actual systems, but we lack proof sufficient to force that recognition on populations not prepared for its implications. The ancient texts suggest this graduated revelation serves protective purposes. Full immediate knowledge could produce social disruption, religious crisis, political instability. Controlled increase in available evidence allows progressive adjustment, gradual development of explanatory frameworks, integration of disturbing information without catastrophic disruption. The methodology resembles how complex truths are taught to developing minds, revealing progressively as comprehension capacity increases. Whether this interpretation reflects actual design or represents rationalization of ambiguity that has no deeper purpose cannot be determined from within the situation. We cannot know whether the difficulty of confirmation is intended feature or accidental limitation, whether the questions are meant to be asked at this historical moment, or whether they have simply persisted through time without particular significance. The ancient accounts cannot answer these meta-questions. They can only preserve their claims and wait for each generation to decide what weight to give them, what effort to invest in investigation, what consequences to accept for either believing or dismissing their warnings. The decision about investigation carries practical consequences beyond intellectual curiosity. If the ancient texts document actual monitoring systems and humanity is approaching thresholds that trigger responses, then understanding those systems becomes strategically important rather than merely academically interesting. The difference between metaphorical warning and technical documentation determines whether caution is philosophical prudence or operational necessity. The challenge is that investigation itself may constitute threshold-crossing behaviour. If monitoring systems exist and track human knowledge acquisition, then attempting to locate and analyse watcher installations might register as exactly the kind of boundary violation that triggers responses. The ancient texts describe forbidden knowledge, information that was deliberately restricted because accessing it represented dangerous capability, rather than merely learning interesting facts. The Enochic tradition emphasizes that certain knowledge was prohibited not because it was morally corrupting, but because it was operationally dangerous. The astronomical observations, the metallurgical techniques, the genetic manipulation procedures, these were restricted because possessing them enabled actions whose consequences exceeded human capacity to predict or control. The restriction aimed at preventing capability mismatch rather than maintaining ignorance for its own sake. Modern scientific investigation operates under different assumptions: that knowledge is inherently neutral and that understanding always serves beneficial purposes. This framework treats restrictions on knowledge as unjustified, attempts at control rather than as potentially legitimate safety protocols. The tension between these perspectives creates practical dilemmas about how to proceed with investigating ancient claims. If we treat the texts as mythology and investigate freely, we risk crossing boundaries that might actually exist and that might trigger responses we are not prepared to handle. If we treat the texts as literal documentation and avoid investigation out of caution, we remain ignorant about questions whose answers might be important for our trajectory. The optimal approach is unclear when operating under uncertainty about whether the warnings describe actual dangers. The ancient texts suggest that this uncertainty itself represents a filtering mechanism, that civilizations mature enough to investigate carefully, weighing potential consequences against curiosity, demonstrate qualities that qualify them for knowledge access, while civilizations that investigate recklessly without considering whether boundaries might exist for legitimate reasons demonstrate immaturity that justifies continued restriction. This framework implies that how we approach investigation matters as much as what we discover, that demonstrating appropriate caution, even when we cannot confirm whether caution is necessary, shows developmental characteristics relevant to evaluation. The test is not merely what we can discover, but what judgment we exercise in deciding whether to pursue discovery. The ancient texts describe this as the fundamental distinction between wisdom and mere knowledge. Knowledge is capability, understanding how systems function and how to manipulate them. Wisdom is judgment, understanding when capability should be exercised and when restraint serves larger purposes. The text suggests the Watchers valued wisdom more highly than knowledge when evaluating human readiness for advancement. Modern technological culture tends to conflate knowledge and wisdom, treating them as synonymous, or assuming that knowledge automatically produces wisdom. But the historical record shows repeated instances of capability being used without adequate consideration of consequences, of knowledge advancing faster than judgment about its appropriate application. The pattern the ancient texts describe as triggering previous interventions. Whether we are repeating that pattern or whether we are developing the wisdom to accompany our knowledge represents the question that our current era must answer through demonstrated behaviour rather than merely stated intentions. The ancient texts suggest that this demonstration is being observed and evaluated if the monitoring systems they describe actually exist. The evaluation criteria, according to these texts, focus on collective behaviour rather than individual achievement, that civilizations are judged by their institutional structures and societal patterns rather than by exceptional individuals, that the presence of wise persons matters less than whether wisdom influences actual decision-making about consequential technologies. This emphasis on collective capability explains why the ancient texts describe both teaching programs and genetic modifications. Individual genius is insufficient if society lacks structures for translating that genius into collective wisdom. The Watchers apparently attempted to create both capable individuals and institutional frameworks that would enable wise governance. The pre-flood failure suggested that the balance was not achieved, that capability exceeded institutional capacity to manage it responsibly. Modern civilization faces similar imbalance. We have produced remarkable individual accomplishments in scientific understanding and technological capability, but our institutions for collective decision-making about consequential technologies remain primitive relative to the powers they must govern. International coordination is weak, enforcement mechanisms are limited, and short-term incentives often overwhelm long-term consequence consideration. The ancient texts describe this institutional inadequacy as the core problem that the flood was designed to address. Not that humans were inherently flawed, but that they lacked organisational structures adequate for managing the capabilities they had acquired. The post-flood modifications apparently included not merely genetic limitations, but also establishment of governance systems, the institution of kingship, the creation of priestly hierarchies, the development of administrative bureaucracies. These structures were supposedly designed by the Anunnaki to provide frameworks for collective decision-making that would prevent the institutional inadequacy that characterized pre-flood civilization. The texts describe how governance systems were taught rather than independently evolved. how the Anunnaki provided templates for political organisation, legal codes and administrative procedures. The Code of Hammurabi, one of the earliest comprehensive legal codes, describes itself as divinely revealed rather than humanly invented. The text presents Hammurabi as receiving the laws from the god Shamash, who instructs him in principles of justice and governance. Whether this represents actual knowledge transfer or merely claims to divine authority for human-created laws cannot be determined from the text alone. But the sophistication of early legal codes creates chronological puzzles. The principles of proportional justice, the concepts of evidence and testimony, the frameworks for property rights and contract enforcement, these appear essentially complete in the earliest legal texts, rather than showing gradual development. The pattern suggests either remarkably rapid indigenous invention or transmission of legal concepts from sources that had already developed them. Similar patterns appear in administrative systems. The bureaucratic structures that govern Mesopotamian cities show organizational sophistication that typically requires extended evolution. Record-keeping systems, taxation frameworks, resource allocation mechanisms, these appear in early Sumerian texts as functioning systems rather than experimental innovations. The completeness suggests inherited templates rather than original invention. The ancient texts attribute these organizational frameworks to Anunnaki instruction, describing how governance structures were established as part of post-flood reconstruction. The claim is that these systems were designed to provide institutional capacity adequate for managing technological capabilities that humans would eventually redevelop. That governance frameworks were intentionally created to match anticipated technological advancement. If accurate, this represents remarkably sophisticated social engineering, designing institutions that would remain functional across millennia while civilizations gradually rebuilt technological capabilities. The longevity of basic governance structures established in ancient Mesopotamia supports the possibility that they were indeed designed for durability, rather than merely reflecting temporary solutions to immediate problems. But institutional structures designed for ancient technological levels may be inadequate for modern capabilities. The governance frameworks that sufficed when human impacts were local and reversible face greater challenges when technologies produce global and potentially irreversible consequences. The question is whether our institutions have evolved sufficiently to match our technological advancement, or whether we face the same capability governance mismatch that characterized pre-flood civilization. The ancient texts suggest that this mismatch is precisely what monitoring systems would track. That evaluation focuses not on technological achievement, but on whether institutional capacity keeps pace with capability. That the critical assessment involves whether civilizations develop governance structures adequate for managing the powers they acquire. By these criteria, modern civilization presents concerning patterns. Our technologies affect global systems, climate, ecosystems, genetic diversity, but our governance remains largely national. Our capabilities produce consequences spanning centuries: nuclear waste, genetic modifications, artificial intelligence, but our political systems optimize for electoral cycles measured in years. The temporal and spatial mismatch between technological impacts and governance capacity suggests institutional inadequacy comparable to what the texts describe as triggering previous interventions. Whether this inadequacy triggers automatic responses from monitoring systems, or whether it represents a test of our ability to self-correct before reaching critical thresholds, depends on assumptions about how such systems operate. The texts suggest both automatic safeguards and evaluative judgment. Some boundaries enforced mechanically, others assessed contextually. The uncertainty about which mechanisms apply to specific situations creates strategic ambiguity. We cannot know whether particular technological developments will trigger automatic responses, or whether we have latitude to experiment within monitored boundaries. The safe approach assumes restrictive interpretations, that boundaries are real and enforcement is automatic. The ambitious approach assumes permissive interpretations, that we have freedom to explore until explicitly constrained. The ancient texts suggest that choosing between these approaches itself represents the evaluation, that mature civilizations err toward caution when consequences are uncertain, while immature civilizations prioritize capability demonstration over consequence consideration. The choice reveals values and judgment that matter more than the specific outcomes of individual decisions. This framework places responsibility squarely on our choices rather than on external constraint. We are not prevented from pursuing dangerous technologies, but are expected to exercise self-restraint when pursuing them could produce unacceptable consequences. The management system, if it exists, apparently operates through influence on judgment rather than through direct control of behaviour. The texts describe how the Anunnaki established cultural frameworks, religious teachings, ethical principles, wisdom traditions that would influence human decision-making without requiring constant direct intervention. These frameworks were designed to internalize restrictions, to make humans self-regulating, rather than requiring external enforcement. The success of this approach depends on whether cultural transmission maintains the frameworks across generations. Modern secular civilization has partially abandoned these traditional frameworks while not fully replacing them with alternative ethical systems adequate for governing advanced technologies. The result is philosophical uncertainty about which principles should guide consequential decisions. The ancient restrictions on forbidden knowledge have been rejected as superstitious limitations, but comprehensive ethical frameworks for technological governance remain contested and incomplete. The text suggests that this represents exactly the dangerous transition period that requires most careful monitoring, when traditional constraints are weakening but replacement systems are not yet established, when capability is expanding but wisdom traditions that might guide its application are losing influence. The vulnerability point where civilizations either successfully navigate toward mature self-governance or fail into patterns requiring external correction. Where we are in this transition remains uncertain. Whether we are successfully developing new ethical frameworks adequate for technological governance, or whether we are drifting toward the kind of institutional failure that the texts describe as necessitating intervention. The outcome depends on choices being made across multiple domains: technological, political, cultural, philosophical, whose collective impact determines our civilizational trajectory. And beneath all analysis remains the question of whether anyone is actually watching, or whether we navigate these challenges entirely on our own. The watching question matters because it determines the nature of the stakes. If we navigate technological challenges in isolation, with consequences affecting only ourselves and our planet, then our choices represent local experiments whose outcomes remain confined to our system. The worst-case failures would be terrible for humanity and Earth's biosphere, but would not ripple beyond that scope. We succeed or fail on our own terms in our own time, with no external judgment about the outcome. But if the ancient texts document actual monitoring systems embedded in larger frameworks of cosmic administration, then our choices carry significance beyond their immediate effects. We become test cases for whether particular developmental pathways produce viable outcomes. Our failures or successes inform decisions about whether similar approaches should be attempted with other populations. The consequences extend to contexts we cannot perceive and involve considerations we were never told we needed to satisfy. This possibility creates a peculiar form of moral weight. We are potentially responsible not merely to ourselves and future human generations, but to evaluative frameworks that assess our civilization according to criteria we do not fully understand. The ancient texts hint at these criteria: wisdom, restraint, institutional adequacy, appropriate relationship between capability and judgment, but they do not provide definitive thresholds or clear measurements for evaluation. The ambiguity may be intentional. If evaluation criteria were made explicit, civilizations could optimize for satisfying those specific requirements without developing genuine wisdom. The test becomes about gaming the metrics rather than achieving actual maturity. By leaving criteria somewhat vague while providing general guidance through preserved texts, the system encourages authentic development rather than superficial compliance. This framework assumes remarkably sophisticated design in how knowledge was preserved and transmitted. The ancient texts would need to contain sufficient information to warn about genuine dangers, while remaining ambiguous enough to prevent rule following that substitutes for wisdom. The balance is delicate: too little information, and civilizations proceed ignorantly into catastrophe. Too much specificity, and they optimize for appearing wise rather than becoming wise. Whether the ancient texts actually achieve this balance, or whether they simply represent inconsistent mythological traditions that happen to contain interesting ideas, is the question that cannot be resolved without accepting one interpretive framework over others. The texts can be read as sophisticated designs for graduated knowledge revelation, or they can be read as primitive attempts to explain natural phenomena through supernatural frameworks. Both interpretations account for the available evidence, though they lead to very different conclusions about implications. The practical question is, which interpretation provides better guidance for navigating current challenges? If we assume monitoring systems exist and govern our choices accordingly, exercising caution with powerful technologies, developing institutional capacity before expanding capability, prioritizing wisdom over mere knowledge, then we invest resources in restraint and careful evaluation that might be unnecessary if the texts are merely mythology. But the costs of this cautious approach are limited. Developing better governance structures serves beneficial purposes regardless of whether monitoring systems exist. Exercising restraint with dangerous technologies reduces risks that are real, even if no external evaluation occurs. Building institutional capacity for wise decision-making produces value whether or not anyone is watching. The precautionary approach serves our interests even if the specific framework motivating it proves incorrect. Conversely, if we assume the texts are mythology and proceed without the caution they recommend, pursuing capabilities aggressively, accepting governance inadequacies as temporary problems to be addressed later, prioritizing technological advancement over wisdom development, then we face significant risks if monitoring systems actually exist, and we trigger responses by crossing boundaries we did not take seriously. The asymmetry of consequences favours the cautious interpretation. The costs of believing incorrectly in monitoring systems are moderate and arguably beneficial regardless. The costs of disbelieving incorrectly in monitoring systems could be catastrophic if they exist, and we trigger corrective interventions by demonstrating exactly the kind of reckless advancement that previous cycles supposedly exhibited before their resets. This logic resembles Pascal's wager about religious belief, but with a significant difference. Pascal's wager involves costs in earthly life, potentially offset by infinite rewards or punishments after death, a framework that requires accepting religious metaphysics. The monitoring system question involves near-term risks that are accessible through analysis of technological consequences, regardless of whether external evaluation occurs. The precautionary approach produces benefits that justify themselves even absent monitoring systems: better governance, more careful technological development, greater emphasis on wisdom. These improve outcomes for reasons independent of whether anyone is watching. The framework motivates beneficial choices through concern about external evaluation, while producing results that serve internal purposes. The ancient texts may function exactly this way, regardless of whether they document actual monitoring systems. They preserve warnings about patterns that produce catastrophic outcomes, following their guidance about caution with powerful technologies, developing adequate governance, prioritizing wisdom over capability. These recommendations serve our interests, whether motivated by fear of external judgment or by recognition of inherent dangers. This pragmatic interpretation allows benefiting from the text's wisdom, without requiring definitive resolution about whether they describe actual oversight systems. We can adopt their recommendations for reasons they suggest, concern about monitoring and evaluation, while recognizing that the recommendations serve purposes that remain valid even if the motivating framework proves incorrect. But this pragmatic stance sidesteps the deeper question about reality. Whether monitoring systems exist matters for understanding our actual situation, not merely for deriving behavioural guidance. If we are observed and evaluated, then our relationship to reality is fundamentally different than if we navigate challenges alone. The question is not merely practical but ontological, about what kind of universe we inhabit and what our place within it actually is. The ancient texts describe a universe in which Earth is not isolated but is embedded in larger administrative structures, in which humanity is not autonomous but is managed as part of cosmic programs, in which our development follows pathways that were established by entities whose purposes we do not fully comprehend. This is a very different universe than the one described by modern cosmology, where Earth is an ordinary planet orbiting an average star in one galaxy among trillions, where humanity emerged through purely natural processes, where our development follows pathways determined entirely by physical laws and historical contingency. The conventional cosmology positions humanity as insignificant on cosmic scales, but autonomous within our local context. We matter little to the universe, but control our own trajectory. The ancient text's cosmology positions humanity as significant enough to warrant oversight, but constrained by that oversight. We matter to larger systems, but do not control our own trajectory entirely. Each framework has psychological and philosophical implications. The conventional view supports human autonomy, but can produce existential anxiety about cosmic meaninglessness. The ancient text's view provides cosmic significance, but threatens human autonomy with external management. Neither is obviously preferable. The choice between them depends on values about whether meaning or freedom matters more for human flourishing. But the choice should not be made on preference alone. The question is not which universe we would prefer to inhabit, but which universe we actually inhabit. Whether monitoring systems exist is a factual question, even if it cannot currently be answered definitively. The appropriate response is to continue investigating while acknowledging uncertainty, rather than to choose belief based on which implications we find more comforting. The ancient texts preserve accounts that allow investigation to continue. They provide specific claims that could in principle be tested, locations where installations should exist, genetic markers that should appear in certain populations, astronomical correlations that should be detectable. The investigation remains incomplete, not because questions cannot be formulated, but because accessing the relevant data faces practical obstacles. Some obstacles are technical. Underwater archaeology at significant depths requires expensive equipment and specialised expertise that limits exploration pace. Underground sites in geologically active regions face risks that make comprehensive excavation difficult. Genetic analysis of ancient populations requires sample quality that is often unavailable from relevant time periods and locations. Other obstacles are political. Many sites the texts identify as significant lie in territories where governments restrict archaeological access for religious, security or sovereignty reasons. International cooperation required for comprehensive investigation faces challenges from competing national interests and different priorities about historical research versus other concerns. Still other obstacles are institutional. Academic archaeology operates under methodological constraints that make investigating claims associated with ancient astronaut theories professionally risky. Researchers who take these questions seriously face skepticism from colleagues and potential damage to career prospects. The institutional incentives favour conventional interpretations even when evidence might support alternative frameworks. These various obstacles mean that investigation proceeds slowly and incompletely, but progress continues. Underwater archaeological technology improves, enabling exploration of sites that were previously inaccessible. Genetic analysis techniques advance, allowing extraction of useful data from degraded samples. International cooperation occasionally enables investigation of restricted sites. Academic attitudes gradually shift as anomalous evidence accumulates. The trajectory suggests that over coming decades, we will have substantially more data relevant to evaluating ancient texts' claims. Underwater sites will be systematically surveyed. Underground installations will be comprehensively mapped. Genetic databases will expand to include more ancient populations. The questions that currently remain unresolved due to insufficient evidence may become answerable as investigation continues. Whether that investigation produces evidence supporting the monitoring system hypothesis or definitively refutes it remains to be seen, but the questions are increasingly being treated as legitimate areas for research rather than merely fringe speculation. The shift from dismissal to serious investigation represents progress regardless of what conclusions eventually emerge. And in the meantime, we navigate technological challenges that carry significant consequences whether or not anyone is watching. The choices we make about genetic engineering, artificial intelligence, space exploration, and other threshold technologies will determine outcomes that matter for reasons independent of external evaluation. The ancient texts' warnings serve purposes whether they document actual monitoring systems or merely preserve wisdom about inherent dangers. The night deepens, the questions remain. And somewhere between what we know and what we wonder, the ancient accounts wait with their patient claims about watchers and thresholds and civilizations that came before. The patience of the ancient accounts is itself noteworthy. The texts were preserved through catastrophes, cultural transitions, linguistic transformations, maintained by scribes who copied tablets they could no longer fully understand, by priests who performed rituals whose original purposes had been forgotten, by cultures that valued the texts enough to protect them across millennia even when their operational significance was lost. This preservation suggests that something about the texts remained valuable even when their technical content became opaque. They functioned as religious literature, as cultural identity markers, as connections to ancestral wisdom, serving purposes that justified the enormous effort required to maintain them across generations. The multi-layered functionality enabled survival through periods when any single interpretation might have failed to motivate continued preservation. The Sumerian cuneiform tradition lasted approximately 3 millennia before disappearing in the early centuries AD. During those 3,000 years, the tablets were copied, recopied, translated between languages, transmitted across cultural boundaries. The knowledge they contained about astronomical observations, mathematical principles, and historical claims remained embedded in texts whose religious and cultural significance ensured their protection. When cuneiform finally ceased to be written, the knowledge encoded in those texts became inaccessible for over 15 centuries. The tablets lay buried in ruins of ancient cities, unreadable to populations that no longer possessed the linguistic keys. The information was preserved but locked, existing in physical form but unavailable for use until decipherment efforts in the 19th century recovered the ability to read the ancient scripts. This 15th century gap between the end of cuneiform writing and its modern decipherment represents exactly the kind of knowledge discontinuity the ancient texts describe as recurring through history. Civilizational collapse disrupts information transmission, leaving subsequent cultures to rediscover or reconstruct knowledge that previous populations had possessed. The pattern the texts identify as characteristic of post-catastrophe periods, the fact that we can now read these texts, that archaeological excavation recovered them from ruins and linguistic scholarship deciphered their languages, means we have regained access to knowledge that was temporarily lost. We are in some sense post-discontinuity civilization that has recovered records from pre-discontinuity sources. The recovery enables us to learn what those earlier cultures knew and what they considered important enough to preserve. What we find in those recovered texts is sophisticated astronomical knowledge, advanced mathematical calculations, detailed chronologies of immense time, periods, and consistent claims about non-human entities that established civilization's foundations. The sophistication argues against dismissing the texts as primitive mythology. The consistency across independent sources suggests shared information rather than coincidental invention. The specificity of technical details indicates that something real was being documented, but the gap between when the texts were written and when we regained ability to read them creates uncertainty about how much was lost in transmission. The tablets we have recovered may represent only fragments of larger knowledge systems. The texts may refer to other documents that have not survived. The technical terminology may have been corrupted through copying errors that accumulated across centuries. We may be working with incomplete and degraded versions of information that was originally more comprehensive and precise. This uncertainty is built into the situation. We cannot recover what was lost during the discontinuity period. We cannot know what additional texts existed in libraries that were destroyed or remain buried in unexcavated sites. We cannot be certain that the meanings we extract from ancient technical terminology accurately reflect what the original authors intended. We work with what survived, acknowledging that survival is imperfect. Yet what survived is remarkable. The astronomical precision encoded in monuments and texts indicates knowledge that required centuries of observation to accumulate. The mathematical sophistication demonstrated in architectural proportions and calendrical calculations shows capabilities that supposedly did not exist in those periods. The consistency of flood narratives across independent cultures suggests shared memory of actual events rather than merely parallel mythological development. The cumulative pattern of surviving evidence supports the ancient texts' claims that knowledge was inherited from earlier sources rather than invented by each civilization independently. Whether those earlier sources were pre-flood human civilizations or non-human entities that the texts call Anunnaki or Watchers remains the unresolved question. But that knowledge transmission occurred from sources predating the historical civilizations that recorded it seems increasingly difficult to deny. This knowledge transmission framework requires accepting that sophisticated understanding existed during periods when conventional chronology places only primitive populations. It requires acknowledging gaps in the archaeological record where advanced civilizations might have existed but left limited traces, perhaps because their cities were concentrated in coastal regions now underwater, or because catastrophic events destroyed most physical evidence, or because preservation conditions prevented survival of materials that would document their existence. The underwater archaeological sites discovered off India, Japan, and the Mediterranean demonstrate that urban development did occur in areas now submerged. The Younger Dryas impact evidence confirms that catastrophic events did destroy civilizations during periods when the flood traditions place their narratives. The preservation bias in archaeology toward stone structures means that civilizations that built primarily with organic materials would leave minimal traces even if they were sophisticated. Each of these factors individually provides plausible explanation for why advanced pre-flood civilizations might not appear prominently in the conventional archaeological record. Collectively, they suggest that absence of evidence is not evidence of absence, that our current picture of human development may be incomplete because significant portions of the record were destroyed, submerged, or built with materials that did not preserve. The ancient texts provide frameworks for understanding what that missing record might contain. They describe urban civilizations possessing advanced knowledge during periods thousands of years before conventional chronology places such development. They attribute this knowledge to teaching from non-human sources and document its partial preservation through catastrophic events that disrupted but did not entirely eliminate the information. Whether these frameworks accurately represent historical reality or whether they are mythological constructs that ancient peoples used to explain knowledge whose actual origins they did not understand remains the question that evidence has not yet definitively answered. But the question is increasingly being recognized as legitimate rather than merely speculative. The evidence is sufficient to justify serious investigation, even if it does not yet compel specific conclusions. And that investigation continues. Each underwater site surveyed, each ancient text translated, each genetic sequence analysed adds data that either supports or challenges various interpretative frameworks. The accumulation is gradual, and the pattern that emerges remains ambiguous. But the direction is toward more information rather than less, toward better understanding rather than continued ignorance. The ancient texts themselves seem designed to enable this gradual revelation. They preserve information in forms that remain accessible across multiple interpretive stages, functioning as a religious literature for populations not yet ready for technical interpretation, then as historical documents for populations that develop capability to recognize embedded knowledge, then potentially as operational manuals for populations that develop capability to use the preserved information. If this graduated revelation is intentional design, it represents sophisticated information encoding, structuring knowledge so it survives across civilizational collapses while becoming progressively more useful as recovering civilizations redevelop capability to extract technical content. The methodology would ensure that knowledge remains available when needed without requiring continuous institutional maintenance across discontinuity periods, whether the texts actually represent such sophisticated design or whether they accidentally possess characteristics that enable multiple interpretations depends on assumptions about the intentions of their original authors. If the authors were merely recording mythology, then the technical interpretations we find may represent our projections rather than their intentions. If the authors were deliberately encoding knowledge for future recovery, then technical interpretations may align with their actual purposes. The texts themselves cannot definitively resolve this question, but certain features suggest intentionality. The precision of astronomical data embedded in monument proportions, the consistency of numerical relationships across independent cultural traditions, the multi-layered structure that allows text to function simultaneously as religious narrative and technical documentation. These characteristics would be difficult to produce accidentally. The alternative, that ancient peoples accidentally created texts that function as sophisticated information encoding systems while intending merely to record religious beliefs, requires accepting that remarkable effectiveness emerge without design. That is possible, but seems less parsimonious than accepting that the texts may function as designed because they were actually designed for these purposes. If the texts were designed for graduated knowledge revelation, then we may be approaching the stage where the next layer becomes accessible, where technical content that has remained embedded but unrecognized becomes interpretable as our capabilities develop, where information that survived through discontinuity periods becomes operational again as we recover ability to understand and use it, what that next layer might contain, what knowledge might be encoded in texts we have read multiple times without recognizing all they preserve, remains unknown. But the possibilities suggest that continued investigation of ancient sources may yield insights that go beyond historical interest to provide knowledge relevant for current challenges. The ancient texts describe cycles of civilizational rise and fall, knowledge gained and lost, advancement and regression. They suggest that we are not the first to face challenges of managing powerful technologies or developing adequate wisdom to accompany capability. They imply that previous cycles provide lessons relevant for our trajectory, if we can extract those lessons from accounts that have survived across multiple civilizational discontinuities. Whether those lessons involve merely philosophical insights about wisdom and restraint, or whether they include technical knowledge about monitoring systems and evaluation criteria, or whether they preserve information about entities that may still observe our development, these remain questions that investigation continues to address but has not yet answered. The night holds both questions and silence. The ancient accounts persist in their patient preservation, and somewhere between documented history and inherited memory, the possibility remains that we are not navigating these challenges alone. The question of companionship in navigation, whether we face these challenges with or without external observation, cannot be separated from the question of what we hope the answer will be. The human response to the possibility of monitoring systems is not neutral. Some find the idea comforting, suggesting that our struggles matter to larger frameworks and that guidance may be available if we demonstrate readiness to receive it. Others find it threatening, implying that autonomy we assumed we possessed is actually constrained by oversight we cannot opt out of. These emotional responses shape how evidence is interpreted. Those who hope for cosmic significance may be more willing to see technological interpretations in ancient texts, to treat anomalous precision as evidence of transmitted knowledge, to accept that monitoring systems might exist. Those who value autonomy may be more inclined to conventional explanations, to treat precision as coincidental or exaggerated, to insist that extraordinary claims require extraordinary evidence. Neither emotional preference constitutes evidence for or against the actual existence of monitoring systems. The universe does not arrange itself according to what we find comforting or threatening, but our preferences affect what we investigate, what evidence we prioritize, and what conclusions we find persuasive. The inability to fully separate analysis from preference is built into the situation. The ancient texts seem aware of this human tendency. They preserve their claims without providing proof sufficient to compel belief, leaving space for choice about interpretation. The ambiguity may serve filtering purposes, ensuring that only those who find the framework compelling enough to investigate despite uncertainty will pursue the knowledge that investigation might reveal. This creates a self-selecting pattern where belief and evidence become intertwined. Those who find the monitoring system hypothesis plausible invest effort in investigation, which generates evidence that reinforces their interpretation. Those who find the hypothesis implausible invest less effort, which means they encounter less evidence that might challenge their interpretation. The pattern produces divergent evidential assessments based partly on different investigation levels, rather than merely on different interpretations of identical data. Breaking this pattern would require comprehensive investigation by researchers with diverse initial perspectives, ensuring that evidence is collected and analysed regardless of what interpretations investigators prefer. But funding limitations, access restrictions, and career incentives make such comprehensive neutral investigation difficult to organise. The research that occurs is conducted primarily by those already inclined toward particular interpretations. This is not unique to ancient text interpretation. Many research areas face similar challenges, where initial perspectives shape what is investigated and how results are interpreted. The solution involves transparent methodology, replication by independent researchers, and institutional structures that reward discovery regardless of whether it supports or challenges prevailing frameworks. These practices improve gradually, but remain imperfect. The ancient texts will continue to be interpreted through multiple frameworks, as sophisticated knowledge encoding systems by some researchers, as mythological constructs by others, as mixture of historical memory and religious elaboration by still others. Each framework accounts for some evidence while struggling with other data. The competition between interpretations drives investigation forward, as proponents of each view seek evidence that supports their position. This competitive investigation serves useful purposes even if it does not quickly resolve to consensus. Different frameworks generate different predictions about what evidence should exist and where it should be found. Following these predictions produces discoveries that inform understanding regardless of which framework ultimately proves most accurate. The process generates knowledge even while debate about interpretation continues. What remains certain is that the ancient texts document something significant. Whether they describe actual monitoring systems or merely preserve human attempts to understand their world during formative periods, they represent sophisticated intellectual achievements that reward continued study. The astronomical precision, the mathematical relationships, the consistent narratives across cultures, these are not the products of primitive minds, but of capable observers attempting to document and transmit what they understood. The respect we accord to these ancient voices, treating their accounts as potentially meaningful rather than dismissing them as mere superstition, reflects our own intellectual humility. The recognition that people separated from us by millennia may have perceived or understood things we have forgotten or never learned. The possibility that knowledge can be lost and must be recovered, rather than merely progressing linearly forward. The Sumerian King List with its impossible chronologies, the Anunnaki texts with their detailed watcher accounts, the Egyptian records with their descriptions of the first time. These documents preserve claims that challenge our assumptions about human development and cosmic isolation. Whether those challenges ultimately lead to revised understanding or to confirmed conventional frameworks, the engagement with them expands our thinking about possibilities, and in that expansion lies value regardless of final conclusions. The questions themselves about our origins, our place in larger contexts, our relationship to knowledge and wisdom are worth asking, even if definitive answers remain elusive. The ancient texts keep these questions alive across generations, ensuring that each era re-examines them with new evidence and fresh perspectives. Perhaps that is their ultimate purpose, not to provide final answers, but to maintain productive uncertainty, to prevent premature closure on questions whose full resolution may require evidence we do not yet possess, or perspectives we have not yet developed, to keep open the possibility that reality is more complex than current frameworks accommodate. The texts describe a seventh civilization, a cycle before recorded history, when advanced knowledge existed and was partially lost through catastrophe. Whether this represents historical memory, mythological construction, or something between those categories remains uncertain. But the claim itself serves purposes, reminding us that our civilization is not necessarily the first to face challenges of managing powerful technologies, that others may have preceded us and failed or succeeded in ways we might learn from. The number 7 carries symbolic weight in ancient numerology, representing completion, wholeness, cycles that repeat. Whether the 7th civilization represents literal historical claim or symbolic statement about recurring patterns is perhaps less important than what it suggests about human development as cyclical rather than linear, that progress is not guaranteed, that advancement can be lost, that each civilization must earn its continuation through demonstrated wisdom. These are sobering recognitions. They challenge progressive narratives that assume continuous improvement and guaranteed advancement. They suggest that our technological capabilities could exceed our wisdom to manage them, producing outcomes that require starting over from reduced foundations. They imply that the stakes of our choices are higher than we might prefer to acknowledge, but they also suggest that recovery is possible, that knowledge can survive catastrophes through careful preservation, that civilizations can rebuild from survivors who maintained fragments of understanding, that the cycles continue, with each iteration potentially learning from previous experiences if the lessons were adequately preserved. The ancient texts represent such preservation, encoded knowledge from previous cycles, whether those cycles were previous civilizations or merely earlier phases of continuous human development. The knowledge they preserve remains accessible to those who investigate carefully, who balance skepticism with openness, who pursue evidence without predetermined conclusions. The investigation continues. The evidence accumulates. The patterns emerge gradually from noise, and somewhere in the space between what we can prove and what we suspect, the ancient accounts maintain their watch, preserving claims about origins, about teachers, about cycles of rise and fall that may describe our past and potentially our future. The questions they pose do not demand immediate answers. They ask for continued attention, careful thought, and willingness to consider that the universe may be larger and stranger than our current frameworks encompass, that Earth may not be as isolated as modern cosmology suggests, that humanity may not be as autonomous as we assume, that our development may occur within contexts we have not yet fully recognized. These possibilities remain open. The ancient texts keep them that way, not through proof, but through preserved testimony that refuses to be entirely dismissed, through mathematical precision that resists simple explanation, through cross-cultural consistency that challenges independent invention narratives, through questions that persist across millennia because they touch something fundamental about human existence and our relationship to larger realities. The night deepens toward morning. The ancient tablets lie in their museum cases, still holding their secrets. And the question of whether anyone watches our navigation through technological challenges remains suspended between evidence and interpretation, between what we can verify and what we wonder, between the silence of the cosmos and the persistent whisper of texts that claim it was never quite as empty as we learn to believe.